Okay, we've got some questions to start the class right here, and we've got audio going. Good to see you inside of here, Walker. Could you review real quick how to calculate the standard deviation and what is classified as normal? Because I know from class that when the data is normal, you take the range and divide. Yep, Walker, so let's talk about this right here. So the first part of this is how to calculate the standard deviation. So, and good to see you, Adam, in the chat. Walker, we're going to make you a mod. And so let's go right here and let's put in some data inside of Jump. So one, never calculate standard deviation by hand. I cannot say this enough. Do not calculate the standard deviation by hand. It'll drive you mad, and you don't want to go mad. So don't do that. To calculate the standard deviation, the quickest way to do it in Jump is to go here and go to Analyze, and then go to Distribution. And with Analyze Distribution, we're just going to double-click the variable itself. Yep, that's right. You saw it in the announcement probably. I will be there at the meeting at 5. I'm going to bring some treats too. We got some bonus prizes for the BAS meeting. So are you going to be there at the BAS meeting? 5 o'clock BAS meeting tonight. I will be there presenting. We got some fun stuff. This distribution right here is a great example of what we have going on. We've got just the data on the screen, and I can bring it over to Word. One of these days, I would throw some crazy bonus points if someone tells me how I can annotate on my screen using my tablet, but I can annotate if I want by just going right here and taking it and dropping in the picture. So now I have the ability to annotate and kind of talk about what we have right here. So if you think about what we've got the mean and standard deviation together. Now I want you to notice that the mean and the standard deviation are put together, and that is for normal looking data. As in, let's add another pen right here. I'm going to add in a green pen. And so the mean and the standard deviation together are for when the data looks unimodal, symmetric, looks pretty normal. Now over here you see the quantiles, which is when we have data that generally has outliers on it. And if you notice, you've got all of these values right in here, which the middle value is the median. And then on top of that, you do have the IQR. Now the IQR needs to be calculated by hand, and the IQR is 1. The IQR is 1 because the distance between those numbers is 1. It's just Q3, which is the 75th percentile. That is Q3 right there. And this is Q1. Think of it as quarters. It says quartile on it. So that is the first quartile, which is 25%, 1 quarter, 25%. And then 75 is the third quartile. So that is the 75th percentile. 20 minus 19 is the equation we will use because the equation is Q3 minus Q1 for the IQR. And once we do this right here, we can see that the IQR is equal to 20 minus 19, which is a distance of 1. So the IQR is 1. And there's more things we can do with this. I'm open to all questions related to the assignments or anything, but the IQR is going to be 1 right here. We'll make it look a little more like a 1. The IQR is just 1. And this data is so heavily skewed with extreme outliers that we would definitely use the median as a measure of center for this distribution, and we'd use the IQR as a measure of spread. So if a question were to ask what are the proper measures of center and spread, the answer would be the median and the IQR due to the shape of the distribution being so heavily skewed with extreme outliers. So if we never have to do standard deviation by hand, will we ever have to calculate it on the test? Amazing question. The answer is no. Now you might say, well, why do we have to calculate it then? That's what students often ask me. It's like, well, why do we have to calculate? Oh, looks like there was Amber Alert or something. There we go. That scared me. Everyone's phone probably rang at that moment if you're watching live. So the reason we don't do the standard deviation by hand is if you notice this data set right here has 1,308 observations in it. And good to see you. This is Scott, and I'm having trouble with my RStudio knitting. Are you still on campus? Send me. I am currently broadcasting live online. Swing by. I will be on campus tomorrow from 10 to 10:40 before class. I have class at 12:40. So swing by between 10 and 12:40, come to office hours, and we will get it to knit. We will make it knit. Also, if you can't get to knit, especially right now, send me your file and be like, Brian, this won't knit. I think the first assignment's due tomorrow night, but send me your file if you can't get it to knit, and I will knit it for you. It's not something we want to do all semester, obviously, but if you're doing the work and we just need to get it to knit, then we'll get it to knit and we'll figure out what's going on with the computer. So don't let that stop you. Keep doing the work, and then we'll figure out what the knitting problem is. And talking about the 1,308 observations right here, if you did this by hand and you had to find out the deviation squared and the sum of those squared distances and divided by the n-1, if you had to do all of this equation by hand to figure out the standard deviation, it would take a long time. That's why we let software do it for us, So software right here will find the standard deviation. And I will say this, let me show, we're going to do some Brian Inception right here. So one thing you can do, let me do this, stat 201, UTK, 5 number summary. So I've got this video, I'll drop it in the chat, and we might start hearing literally, I won't be able to hear myself, but let me go to the TI tutorials, and so let me bring this down to the page right here. Okay, cool. And now everyone can see. If you go to the Stat 201 YouTube page, there's some additional help things that we have right here. On the Stat 201 YouTube page, there is the TI tutorials, and the TI tutorials have things like the 5 number summary. They have how to install, Mac. Best thing to do is go to the homepage right here. There's me currently live. So I wonder if we reload the page, if it'll show me on the page, and we'll get more Inception. So we're reloading the page now. Did I not reload it? I guess. Oh, wait. Oh, no. That's a bad idea. But there we go. Reload the page. It shows that. Anyways, so if you want to do it on the TI calculator, go here and go to the TI tutorials. We'll click on it just briefly here, and you'll see we got a bunch of TI tutorials in the corner too. I've got this now muted, but I show you how to do the 5 number summary. But in addition to this, you'll see that it does give you the standard deviation. It's actually some of the first numbers it gives. I wish I could draw on the screen, but you want this S sub X right here. That 12.425 is the standard deviation. Yes, and we got some, we'll do Lindsay's question next, and then we've got another question here. Lindsay says, since we don't have to calculate the standard deviation by hand, can we use TI 80s and up on the test? They haven't been allowed in my other classes, so I want to ask. The answer is yes. You can use the TI calculators. And this video right here on the channel, how to do the 5 number summary, very short video, 2 minutes. And I enter in the data and I do it all by hand. I wanted to show people just how to find these things. Looks like someone else made a video, your stat class, 23,000 views. And I wanted my videos just to be short, show how to do it, and that's what I did. And so check out the videos. I've got a lot of videos associated with how to do things on the TI calculator. We will never ask complex questions like how to get the standard deviation on the test, because we don't expect you to get the standard deviation by hand. We could ask you what the median is, and we don't generally ask Q1 and Q3 because we don't expect you to do Q1 and Q3 by hand. Median is a concept we would expect you to do by hand, or you can do it with the calculator. So Nathan asked a question. He's in the 474. Go over the homework 10C, homework 1. So let's do that. I've worked a little bit with the TI Inspires. They are a little different, and they trip me up. Because it's a little different, I'm not as used to them. So even I have to kind of pause. I'm very used to the TI 80 series. All the TI 82, 83s, 84s, 85s I'm very good with. And then when I get to the Inspires, they have like a list. I think you go up to like the stat list at the top. So you go to the stat list at the top, and then you go down, and it has like sub menus. So you don't click the stat button. You go to like the list at the top. And so I figured it out. I just don't have an Inspire, so I don't use it that often. I've been using the TI's 80s since the 90s. Oh gosh. When I was born in 1997. That's a lie. So let's hop over here to the assignment, and let's do homework number 1. So this is question 10C. Okay, let's pretend we didn't do it. And let's take a look right here. Okay, so we're going to delete the output right here and kind of have some fun with this. So this is really cool. If you're for 201, you're actually going to hear some concepts that we'll be hearing next class. So it's interesting to see the things we do in upper level statistics are used in all throughout statistics. So here is something with code where we're going to find, I'm going to make it one thing bigger, nice and super easy to see on the screen right now. What this has is we have a bunch of numbers. Now, imagine you saw these numbers and you wanted to think of how they would look inside of JMP. We're going to do some kind of class inception right here. What you saw in R right there, and we should be getting up. I think my computer's frozen. That's not a good sign. Okay, JMP has frozen. Let's give this one more try. Oh, it's because it had that update. Okay, there we go. Now it's working. We're going to look at these numbers we see inside of JMP right here, and we're going to pretend we're going to see them inside R, and we're going to look inside of JMP. Click this, go away. Those numbers you see right there are just like an Excel spreadsheet. So we're going to go and put 78.2, 91.3, 105.7, 79.4, 89.9, and 93.2. What you see here in JMP, right above me over to the side, and in R in the background, is the same thing being done just 2 different ways. So I can go here to Analyze, Distribution, double-click the variable, and do this. If you notice, we get everything right here, and here's what you'd be looking at inside of JUMP. It's going to show me the 5-number summary. I can get the mean of 89 and the standard deviation. We've got a really great function inside of R that when we take this vector x, we can just go here and go scale. And if you remember that mean of 89 and that standard deviation of 10, guess what it gives me? It gives me the mean right here and the standard deviation. These are the same numbers you saw just a moment ago in the JUMP output. You say, but I didn't get the histogram. You see the same mean and standard deviation. Well, if you really wanted a histogram, we can go right here and we can type hist for histogram. And over there, or right here, because mine's sending it there, we'll send it to the corner for the moment. So we'll go here and we'll do that, and now we have the histogram. And it might look different compared by Binwitz, or does it look exactly the same? It does. And you might say, Brian, I want it to be light green. It's behind my head now. So you might say, Brian, I want it to be light green. Well, I can do that for you too. So let's go here and go to col equals, and can we type light green? I'll be super happy if this works. Green has a G in it. We can do light green. Light green works. There it is. This is behind my head. So you can do that. You can type in all the colors you want. Kind of cool stuff right there. So, so don't worry. Let me make you a mod right here, Ali. It thought because you were typing certain things, and if I make you a mod, it works perfectly fine. But it thought you were typing things. So feel free to retype that message, and you are a mod now. So, and we have Streamlabs on here in case someone were to come in and do something crazy. Streamlabs will stop them, generally speaking, and my mods will stop them too. So you can see all this great stuff going on right here. And now we're getting to the bulk of this question with 10C. So we've kind of experienced what this question has to offer, and we know what the data is. It's just numbers. It's just to remember what we're looking at. Always think about what are you dealing with. You're just dealing with numbers right there. That's what we got. It's just the numbers, and we're just turning it into a mean and a standard deviation, and we're just doing that right here. So what can we do? If we wanted to look at this right here and store the scaling of x, we can go here to x dot standardized. So we've standardized x now. And now let's check. And this is where people get a little confused, because when people take the mean of this, which is just the function mean, and they look at it, they'd say, wait a minute, that's not 0. Well, okay, that number is technically negative 0.1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 4, 5, 5, 4, 9, 7. It's ridiculous. Now with this right here, and thank you, Nathan, for helping out in the chat, this number right here is basically 0. It's just rounding. Nathan, let me make you a mod 2. Sorry, I think it's mad about the NAs. It's weird. Streamlabs needs to calm down a little bit. So Nathan, I'm sorry, Streamlabs is just being Streamlabs. This is basically 0 right here. We can confirm this also that this is basically 0 by doing the following. So let's go right here, and let's go and take this and go to round, and put it inside of a round right here, and round it to 6 decimals, and look at that, it's 0. Now, for the people in the chat, I'm going to give 1,000 points. We throw points out during this too. What should the standard deviation be if things are z-scores? If we just have z-scores, what should the standard deviations of z-scores be? Who knows that in the chat? What should the standard deviations of z-scores be? Any ideas? You can type something very quickly. What should the standard deviations of z-scores be? Z-scores have a mean of 0 and a standard deviation of 1. Ali, nice job in the chat right there. You are correct for 1,000 points right there. Yes, z-scores have a standard deviation of 1 because they've been standardized. That's what a z-score is. It's a standardized unit of measurement. It's how many standard deviations something is above or below the mean. And when we draw our normal curve, which we'll be doing in Stat 201 very soon, when we do the normal curve, let me erase those. The normal curve, this is a little review for Stat 201, then we're going to do the next 474 question. This will be at the end of next lecture for them. If you were to look at something like test scores, then we could have test scores had a mean of 70 with a standard deviation of 5. Maybe this is a pretty tough class right here. And if you look, I'm putting down the in context. I call this the context. And now you could say somebody who has a z-score, we'll put the z-scores in green, a z-score of 0 got the mean, and here is a z-score of 1, 2, and 3. And I'm slightly blocking the third one right there. And then you go down here and you do -1, -2, -3, and we can do our 68, 95, 99.7 rule. But I've turned these all into z-scores right here. I'm just going to lean back from it. So we've turned these all into z-scores right here. So this is what we're doing, and z-scores have a mean of 0. and they have a standard deviation of 1. The original distribution had a mean of 70, so you could draw the original as having it's normally distributed with a mean of 70 and a standard deviation of 5, and the new distribution is normally distributed with a mean of 0 and a standard deviation of 1. And that's the way every z-score is. Every z-score is meant to have a mean of 0 and a standard deviation of 1. So really great questions. Then we got some questions about some NAs. So let's look at dealing with NAs, and they're a bit interesting. And I think this does it. Make sure, double check. Sometimes I do most of a problem, read the full problem to make sure I'm doing all of it. I kind of want to allude to how to do things, and of course not do them immediately, but talk about the concepts on how we do these. So in the chat they asked, will NA.remove bogus values like 999 as well as NA, or does it just remove NAs? And I think, yeah, Nathan, another 1,000 points to Nathan. He says, Ali, you have to assign NA values to those. It doesn't do it for you. That is correct. So let's look at a vector right here. Be careful. Don't write everything I write. I'm going to start a new sheet just in case someone were to be watching this. I think some people watch it on mute and they literally type everything I write. And I'm like, no, don't type everything I write. Look at all this beautiful code right here. We're going to delete this code. I don't want to delete my code. I'm going to open another untitled. So let's hop in here. What we have is a vector of information. And I'm going to put inside of here capital NA. So if you notice, the third value there is missing. Let's look at what this would look like in JMP, which I think can help us to visualize it. Here it is, and what did I do? I went to the third value, and I did that. This is what the data actually looks like if you're looking at it in JMP. There's 6 values. Is there 6? There's 6 values in here, and the third value is missing. Just conceptualize it. NA does not mean the word NA, because if we wanted the word NA, we'd have to put it in quotes. That changes it, and if you notice, the color changes to tell you this is now a character or a string. Now, NA like this is blue because it is a special character. If we type a little more after it, it's going to treat it as a value, and it's going to look for it in the global environment up there. But as you notice, it's not black. It is blue, light blue, a little different from the numeric values up there too. So when you think about this, we can run this and print out our vector right here, not z, but x. And what do we get? We get the same thing we're seeing in JMP. Just to reiterate, it's important to understand what you have. You are literally just dealing with a vector that looks like this. And we'll hop to homework 2 after this. Fun stuff on homework 2. So when you want to find the NAs, and this is really important for this assignment, you can do things like is.NA. And just think about what it says. Is this NA? Well, let's run this. What we should get, and I should have done what I do, we try to pause before we run code and think about what it's going to do, especially when we're learning how to code. So what you notice here is we have false, false, true, false, false, false. So false, false, true, false, false, false. It's seeing if something is NA. What you can also do to have some fun is you could take the whole thing and flip it with an exclamation point. Putting an exclamation point around it, usually I evaluate it, will change the vector from false, false, true, false, false to true, true, false, true, true, true. Might have said one too many trues there at the end. But it just flips all your trues and falses, and that's what exclamation points do. So you can find things that are NA, or you can find things that are not NA just by doing an exclamation point around it. So lots of great stuff right there. If you want to find out how many NAs there are, well, NAs are just zeros and ones. So think about this. All you're going to do for the first vector, and I'll show it down here on the bottom, here's the first vector that I'm evaluating. And I want the sum, and you should think, and we do this sometimes on the test to see if you understand what the code means. We say, you know, what will this code evaluate to? Well, you're just summing up how many trues there are. And if I ask someone how many trues are in that vector, they would say 1. But then we could do a little different thing right here. Instead of doing the sum, we could do the mean. Now, this literally mathematically will solve for the equation 1/6 because there's 1 true over 6 values. So when we do this right here, we get the following right there. We don't have to do NA.remove. That would probably be a really bad idea because we'd probably get 0. This is a bad idea because now we're going to take the mean of a vector where we remove things of NA and we're going to see if there are NAs. So now we get, oh, we do get that still. I guess because it evaluated the inside of that and then it removed the NAs. It's interesting. So it doesn't remove your NAs from the vector because this is where it evaluates the vector. Make sure you know how things are evaluating, and you'll notice. So even I had to think for a moment, and yes, it evaluated this, and then this is only trues and falses. There's no NAs there, and you can sometimes, as a short aside, you can sometimes have an NA on a logical. especially with the lows and the highs on this one. If there's nothing to evaluate, if there's no low value for it to evaluate, you can get an NA for a logical, which means it was not able to evaluate the logical. And Connor asked a question in the chat. He says, homework 2, question 4A. When constructing the data frame, could you give some guidance? Okay, let's do that. I think is this the ring ones? I think you're doing that right there. This is the ring ones. Yep. So it's the EX3 abalone rings. So let me go get homework 2 loaded up. Say hey in the chat. Relax for a moment here. We're just going to have some fun in the chat. Is everyone having a good day? How many people do we have watching right now? I have no idea. It's your chance to say hey. I am almost to the assignments. And let's go here to automation with loops. We've still got 8 days and good job. Here's the biggest thing, and I say this so much. Start on these 474 assignments early because they will just creep up on you. You'll be like, oh my gosh, it's tonight and I haven't even looked at it and I have no idea how to do this. And still attempt it, but you don't want to be in that boat where you are like, I have no idea what's going on. For loops are a little tricky, and we're going to definitely see some help on the for loops right here. This is where you get your practice. The more you can practice it, the better you get. So this is my current code. Let me grab your current code and see what we got. Okay, let me grab your current code. Here we go. Let's grab the code. And let's hop down here. Okay, number 4. I should use this trick, and we go to Q4A, was it? Okay, Q4A. Okay. So we want to create a blank data frame, and it really likes putting that right there. Okay. Data frame decreasing equals true. Something's missing at the end here. So it's mad about something. Oh, we need one more close on it. I think you can see it. I can't highlight on the screen, but if you notice, this is closing right here because you have open, 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 close, close, and then we need close. Let's see what it does. Okay, loading in my packages. EX3 abalone not found. That is in the reg class library. I should have reg class because this computer doesn't reset. So I've got reg class. Reg class is where the EX3 abalone dataset is found. The abalones are a weird sort of sea creature that I think we get meat from. Yeah, it's got meat weight and all that good stuff. Let's see what this did. We got absum. It only has one. It looks like it only has one column in it. Let's see. Okay. Oh, you know what? We're going to change tools. Global options, appearance. Where's code? Display. Where is it where you show the output below? Our markdown. Show output in line for our markdown documents. Show output in line. I can't remember which button I want to click. Let's try that. No. No, come on. This is the one thing I dislike about R. I think I need to decrease font size and it'll fix it. Ay. Let me try. Well, that's going to be fun. Can I go back over to here? Go to general. I have no idea why when you have the screen so big, you can't get it to, you can't get to the button. You need to get to leave this. Let's click enter. It worked. Awesome. Okay, now let's try what I want to happen. Yes, it did it. That's what I want. Okay. We're getting something. Ooh, that's interesting. If you notice, my code now evaluates at the bottom. I like when I run the code right here. This is the way mine is oriented on my computer. Is escape. Oh, yes. I hit enter. Escape might have, to Connor, another 1,000 points. Thank you. I just hate that when you have the font so big because I'm blind, you can't get it to leave. So I've had that problem before. Okay. So we're making a data frame. I think I see the issue. Okay. So yes. Okay. We want right here, you're super close to it. This is the output we want, and we're super close to it. Okay, let's start right here with the first thing that we want in this data frame. Let's go to the very, very first thing we want. And probably a good thing to look at will be EX3 abalone, and let's go to rings. Now, when we look at rings, and there it is down there, I like it evaluating like that. If you look at the rings, we see the values like 3, 4, 5, all the way up to these big numbers. But if you look at this data set up here, this data frame right here, it only has the what values of rings. I want to hear someone say it in the chat. This only has the what values of rings. You only see them one time. And you notice there's no 25, which probably tells me 25 doesn't exist. Starts with a U. It only has the such and such values of rings. It only has the what values of rings. Like, I'm thinking of a code word. Like, it only has the ones that own, like, if it exists, like, it tells us the, starts with a U. It's like, not uni something. The certain values that are, like, if they do appear, like, but they only, unique, that's it. Nice job. 1,000 points right there in the chat. Unique. Okay, so let's try this. Remember, always build your code step by step by step. So let's go here and write unique. And let's grab the unique values of the EX3 abalone rings. So let's grab that, and let's make the data frame from it. Okay, so what do we see right here? We see that we have the unique values of rings. Now, we do have a problem. These are not ordered. So how about we go around this, and we go right here, and we're going to put on this a sort. So I'm going to go sort, and we're going to go inside of it and go, I think it's fine actually, because it does decreasing equals false to start. And there we go right there. So we threw a sort around it. Just think of it as a vector, because all you're doing inside here is taking this vector, and it's just a vector of numbers. Without the sort, if you think about what we get without the sort, we get all the unique values, and it just reports the unique values as they occur. So I did an extra parenthesis. I thought I might have. There we go. So it just reports the unique values, but it doesn't sort them. But now I've sorted the unique values. Now there is a problem also still. If you notice here with this data frame I've created, it's called sort unique EX3 rings. That's the whole name of it. I actually want it to be called rings. So I'm just going to take this name right here. I'm going to plug the name right there. I'm going to copy the name. I'm going to drop it in. And now let's take a look at our data frame. And does the data frame look good so far? Looking pretty good. We're almost there. Now here's the thing I like to do. One, look at what functions you're inside of. The data frame is the outermost function. So we're going to go right here, and this is a new argument inside of data frame. I'll show you briefly here. If we were to be right here, we'd be inside the unique function. If we are right here, we're inside the sort function. And when we're right here, we're still inside the data frame function. Know which function you're currently working in. It can get a little tricky with a lot of parentheses. So if you notice, this is the outermost function. It's the last parentheses. If you click on it, you'll see that this parentheses closes on the data frame. So now we're inside the data frame function. So I'm going to hit comma right here, and I'm going to hit enter. It indents the line because it's part of the function still. So if you literally think of this, this is the first column I'm entering in is rings. And what do we want? I want to see it in the chat. What do we want our second variable to be called? What do we want our second variable to be called? So if you look down below at the lines, you can see what the second variable. You could do, yeah, I think we could rep 0. I think, Connor, 1,000 points, because I was thinking, man, I don't want to enter 0 a whole bunch of times, and I was like, my brain just blipped on the rep. I think I know a trick. I think I have a theory, a game theory, that possibly that'll work. And the answer is, does it work? Does it work? It worked. We could have repped it 24 times, and so this works along with this will be rep 0 24 times. If you're wondering, for people like, what the heck does rep do? It's going to rep 0 24 times, which is the same thing as doing C, comma 0, comma 0, comma 0, comma 0. Like if you just did C and then 0, a whole bunch of these right here, sure, that's 24. And it would do the same thing. It wasn't, but it was close enough. Rather than doing that, you can just tell it to rep, and you could literally tell it to rep how many times you want. So when you do rep, you could just change it to any amount of number you want, and it'll repeat that number that amount of times. Really good way to code it. So with this right here, Connor, how does that look? Did we get the data frame we wanted? I see another question in the chat. Does this look to be what we want? Does that look to be great right there? How's that look? To me, that looks like the proper vector of what we need. Great, that's awesome. And always try to break up the code into parts. Just be like, am I getting exactly what I want here? Am I getting exactly what I want here? I tried sort the first time. Yeah, it's just like, you get so close sometimes you're like, oh, it's reduced. What's it doing? So good stuff. Hey, Brian, it is what from 474. I'm having issues with question 6, part A on homework 1. For some reason, code is outputting 608 rows instead of 7. No. Let's hop back over to homework 1. Let's take a look at this question 6A. So let's take a look at 6A. Let's see what we got. 6A. Is this the one right here? Okay, cool. Okay. I like this question a lot because we just did some syntax stuff a moment ago, and how I like to write code and make it very, very exact. So let's see what this question wants us to do. We are going to create a subset. We're going to call it sub. We only want the movies from 2009, and this is going to be from the movie data frame. So I'm going to load all code above. This is the run all chunks above button. And by clicking the run all chunks above button, I will now load in any data frames I need. So this runs all my code above. Okay, so now we're good start. We have the movie data frame loaded in. So now I need to make a subset of the movie data frame, but here's what we need to do. We need to do this step by step. This is the big thing about coding. Never start by writing every line of code. Let's start by saying subset, and we want to subset the movie data frame. Why not run this? Well, there's no conditions right now. Oh, movie not found. Where's the movie being loaded in? Oh, did I not download it yet? I might not have it downloaded to this computer. We should have. Let's see if I don't have it. We don't have the data frame. So what you need to do is make sure in your files you have the files you need. And on this computer, I do not currently have them. So I'm going to go ahead and download those right now on the assignments page. Just hadn't done this problem yet on this computer. So let's go here to homework 1. I'm doing it off screen at the moment. We're going to download, and I work out of downloads on these computers. So it's just easier. Let me download both data frames. I think I downloaded the by last time. So I think we worked out of that one. And now we have the data frame downloaded. Okay. So not the data frame, the R environment. We downloaded in R environment. To be very clear, I just want to point out what's going on right here. This load function right here is given to you. I'm probably working out of my downloads directory, which is I'm working out of documents, stats1 documents. It's just where I installed it. Ooh, which means that's where the problem is going to lie. So let me, because it's probably not going to work still, because I downloaded it to the downloads. So let me hop back over here and download it to stat201, and then we'll be good to go. So you have to make sure that your RMD file, which is going to be interesting, let me put those files. Let me go and drag these files to stat201 documents. And so let's do that. Or I should set this to downloads. Let me do that. Okay. So much fun right here. So let's do this. Let's go here to documents, stat201, and let's grab the files I just downloaded. And let's go here to downloads. Let's go grab these files. Oh, I already have them. Oh, so that's what it is. You know what I'm going to do? I think I did this right last time. Here's a trick. Wherever so don't save. Let's save selected. Wherever you open up R out of, it'll use that as your working directory. So I'm actually going to my downloads right now and opening R from downloads. So it's actually setting the working directory to here, and I think that's what I did last time. So that's a kind of quick trick right there. Since I opened R from downloads now, downloads is my working directory. Now that can get confusing because maybe you don't want to be working out of that, but be careful. So now when we go to this, since I opened R from my downloads and I have the things in the downloads, let's go back to where we load in the environment and we cross our fingers when we get to the code. Here it is right here. We look at get working directory, and the answer for the working directory is we are in the downloads. And then let's go here and it does load in. So you have to make sure you have your RMD and your R environment in your working directory. My working directory is now downloads because I put in there. Yep, I'll still allow you to come by. Come by, say, hey, get some points. That is excellent right there. So now we're going to go down to question 6. Good to see you here. Definitely swing by. I'll still let you get the points. Let's go here to subset movie, and guess what? We have the movie data frame. So the first argument inside of subset is, what do you want to subset? Awesome. See you then. So what do you want to subset? Now remember, it wanted movies that were only from the year 2009. Well, you can look at what's going on here with movie by bringing this over and just seeing the variables inside of movie. There is a variable called year with a capital Y. So let's only get the movies from 2009 by saying year equals 2009. Now, I want to point out a few things. If you notice, When I click enter right here and I put another condition, I'm going to do and another condition. It kind of goes within this. I can do another and right here. I think we have another condition to do. And it's going to keep doing the kind of inner part. Everything I have right here is all one argument. I want to see in the chat for 1,000 points. All these arguments are the what's for the subsetting. All of these arguments right here are my blanks for how I'm subsetting. This is good review. All of these arguments that I'm writing right now are my blanks for my subsetting. And I won't put a comma because that'll switch the argument. All of these arguments right now are my what's for the subsetting I'm doing. It's a C word. It's like when you're working out. I want you guys to think about it. Like, these are all Brian's what's. I think we still got some 474s in the chat. Conditions right there, Ali, 1,000 points. You are right. These are all my conditions. So if you notice, it's kind of keeping all the conditions like together. It's doing them like you're still within your conditions. That is what we want to know right here. These are all conditions. So one condition is that the year is 2009. And then we have another condition that we want it to have certain ratings. We want these ratings. Now, this is the one people often get confused on. You can use ORs. I would not use ORs. But we go to our next condition, which is this line right here. And we go to rating. And we want to say the rating is contained in the following vector. So the rating is contained in the following vector. Now, this will cause a problem as written right now because these are not words. So I'm going to change these to strings right here because it would see them as a value if I don't put them into quotes. So it's going to search for these words in the vector, not for a value, because if G is alone, it'll look for some sort of value G, not a word G. By putting in quotes, it changes the color to tell you it's a string. Now, we're just going to go back in time a tiny bit here, because every time, and I clicked the wrong button, let's hit page down. Every time you write a little bit of code, especially for stuff like this, please run it. Run your code to see if it works. It worked, we're good. So we have found movies that are in the year 2009 and also have a rating contained in the following ratings. Next, we need to add in a condition right here. I did it. We need to add in another condition. Let's add in an and. There we go. We want to say, and we want the following condition. And the next condition we want is a budget between 10 to 20 million. Okay, so copy paste. We're going to go here to budget. Now, this is where I've seen people make mistakes. I'm going to show you a wrong code here, and then we'll do it a right code. This right here is not going to be the right code. This right here might cause, you notice we only have, what did it give us? Oh, it gave us nothing. It just gave us the column names. What this code did, you're welcome. Glad to help you out, Smooth Keys there. What we have right here is it's telling us we want a budget that has a value contained in exactly 10, 11, 12, 13, like exactly one of these values. We don't want a budget that's exactly one of those values. We want a budget that is, say it with me, greater than 10 million, greater than or equal to 10 million. I think it said containing those values. I'll check that in a second. Greater than or equal to. Okay, good. We've got the budgets that are greater than or equal to. And we could leave this as one line right now. We want a budget that is less than or equal to 20 million. Awesome. If you notice, we have 1, 2, 3, 4, 5, 6, 7. There are the 7 rows you need. If you remember, the question said you will get 7 rows. We're just going to double check that it says greater than or equal to, including these values. So 10 to 20 million, including these values. Next, we need to select only columns. Does selecting columns sound like a condition? Don't overthink it. I'm going to say we want to select columns. We're not saying we want columns equal to this. It's a new condition if you can't tell. New argument means that we are going to put a comma and we're going to go to the new argument. If you notice, it drops back down with the syntax, and then we can say select, and it'll autocomplete, and it'll kind of tell you what's going on right here. Expression indicating columns to be selected from a data frame. Cool. These are the columns we want. Now, columns need to be in a vector, which we're going to select multiple things. That's how we do a vector with the C. So now we go back up here, and we go ahead and we just copy these column names. So we're going to grab these. We're not going to type them because we will make typos. I will. And then we're going to drop it into here. And if you notice, well, one, it didn't copy the backticks correctly. I thought it might, but it didn't. We're going to delete these, and then we're going to use some tricks to make sure it's proper and is not what we want. So here's a trick you might not know in R. If you double-click something and do quotes, it'll put it in quotes. I knew this was not correct because it was not the right color. So it's got these little kind of indicators telling you what's going on. Now, if we run our code and our code works properly, we should have 7 rows and we should have the 4 columns we selected. Make sure you spell everything correctly, especially if you're typing it, but we've now done it. Now, last but not least, we have not saved this into something called sub. I kept running it to make sure I was getting what I wanted, just to be like looking at it each time. So all I do is go sub and just left arrow it into this, and now we've created it. You'll notice we do have the right dimensionality on it over here, where we have 7 observations and 4 variables, which is what we see right here, the 7 rows and 4 variables. And that's got it. That has now subsetted this data set down. Make sure you've got what you want. Well, I guess we can't see the budgets anymore, but assuming that they have the right budgets, we've done it properly. We could double check. If you wanted to double check, you could go right here and just add budget, and you could add, I told you I can't spell. You could add budget, and you could also add year, and we should see budgets between 10 to 20 million, and we should see, so you can view it like an Excel data sheet, and you see budgets between 10 to 20 million for these, and the years are 2009. I don't know any of those movies. Oh, 500 Days of Summer, good movie. So we do know that. The Haunting in Connecticut, New in Town, Bright Star, Freestyle, Gentlemen Broncos, The Fourth Kid. There you go. I'm glad this is helping out. Only one movie was a movie I knew in there. So let's delete off budget right here. And let's delete off year because that's not needed. And when we remake this now, we see we just have the data frame of the following. And once again, we can view it like that. It just looks like an Excel spreadsheet. Additional questions. Who's stuck on anything? What questions are there? 201 320 474. You've got questions. I've got answers. Hopefully. Be bad if I was like, I don't know how to do that one. You got me. That's a tough one. There are some tricky ones. It takes practice and it takes working on the code. And I think one of the biggest things I like to point out is that, especially if you're in 201 right now, I want you to think about what we're looking at here. All we're looking at is the same thing we'd look at inside of Jump right here. Like, it's just a data sheet. But the reason we use code is because we can do things a lot quicker. We can handle larger data frames, and we can kind of choose our own path. Code does not limit you in what you can do. You're only limited by your imagination. And so it's really a powerful way to kind of work through data is to code. And once again, one of my favorite things about this is a lot of the functions we use, like if we wanted to find the mean of this subset, you see how I'm going to go inside of it right there? I can go to running time, and that'll just tell me the average running time for these movies. If I want to change this to standard deviation, we can go right here, change this to standard deviation, and boom, we have the standard deviation. So all of this right here, if we want to turn them into z-scores, we could do our trick from before, which is a hint for the other problems, and we could go here to scale, and we can scale the values just like this. So now all those values have been turned into z-scores very, very quickly. You can do this for large amounts of data or small amounts of data, but you can just get everything you want. If you want to get the summary statistics, which is something we often do, you go here to summary and just go here to sub $ running time, and you get the summary statistics with the min, the max, the Q1, the Q3, the median, and the mean. So it gives you the 5-number summary along with the mean. And I bet, you know what we could do? Because what if someone said, Brian, I want the standard deviation of that? Well, that's the kind of questions we want to work with, because someone could say, wait a minute, I don't want just this, I want the standard deviation. So we're just going to kind of do a Stat 201 474 thing right here. If you notice the way this is formatted, what I'm going to do is I'm going to call standard deviation sub $ of running time. There's the standard deviation of it. I'm going to take this and I'm going to go here and I'm going to append this and I'm going to turn this into a vector. To turn something into a vector, we vectorize this way. And it'll probably be an unnamed position now. Do you see that last position right there is where the standard deviation is at? So I'm going to call this now summary with a capital summary. And then for capital summary, I'm going to go to the names of capital summary. And if you notice, that is the 7th position, which should have no name. See, it's no name. We're going to call that SD. We need to put that in quotes because it's a word. And they capitalize the first letter of theirs. Now if we go summary, we get this right here. But if you notice, one thing I don't like is the way this is ordered. So I can change the ordering of it. I'm going to overwrite summary with summary, and I want the 5-number summary first. So we're going to go to summary, and we're going to go to the positions inside of it. We're going to call first position 1, 2, 3. That's the min, the Q1, the median. Then we're going to skip ahead to the Q3, then the max, then we're going to put the mean after that, and we're going to put the standard deviation. I'm just calling the positions as I go. Position 1, if you remember from down here, is the min, is the min, and then we did the Q1, the median, and then we skipped the mean. We put the mean at the end here because that's position 4. I'm overwriting this with the new positions. So now we go here and we write summary. And guess what? We get it in order. So this is where it's going to get super fun, and I'm alluding to some new stuff. And feel free to ask a question, 201 question or 471 question. Ask anything you want. What we're going to do is we're going to take this, and we're going to call this, let's change this right here. We've got our code we're working with, and we're going to call this Brian summary. So this is some of the fun stuff we'll be doing here in 474, and I do think it's fun. Let's do this right here. We're going to delete this summary right here. We're going to take our code. I see something 10B on homework 1. Let's do that next. Let's take a look at that next. Let's go here, and function takes x, and this is going to be x right here. And so x needs to be this, and there we go. And let's say return summary. Okay. And I think we don't need this standard deviation because that's just print standard deviation. Okay. So let's take a look at this right here. We'll call this Brian sum. And that should run. And if we take a vector of numbers, like if we go to Brian sum and we put inside of here something like empty cars, which is inside of here, and we take miles per gallon, we get it right there. So if you notice, what I created was I created my own custom function right here, which does all that code above, but all I need to run is Brian sum right now, and I can get this to return all that information. So someone could say to me, like if you're working in Stat 201, you're like, hey Brian, use your function to tell me what is the mean, standard deviation, 5 number summary about all of these right here. And I'd run it, and I'd be like, okay, here's all the information you wanted for those numbers, and just gives you it like that. And that's why we use coding, because I can code exactly what I want it to do in the exact order. Like I moved around the positions, I ordered it the way I want, and then my function right here does what I want. Ali asked 10B on homework 1. Let's hop over to that. 10B on homework 1. Let's take a look. 10B says, and thank you for the question in the chat. Where's 10B? Why don't I click these buttons? They exist, and I don't click them. Imagine that a model is made that predicts a transformation in checking balances. So one thing I will say is the numbers up above are slightly different. We will go off these numbers. If you see anything weird in the grading, please tell us. But use the numbers given to you. Sorry about that. I noticed that about a day or two ago. Someone was like, wait, the numbers are different. I was like, oh, they are. I guess that's what happens when we try to change assignments. But use the numbers that are given in the pred right there, standing for predicted or preds. So what do we have right here? We just have a vector of numbers. But this, I want to explain the logic behind this. People with checking balances can go negative. Checking balances are quantitative, and they're going to be a very, very right skew distribution. When you think about an extremely right skew distribution, a lot of the analytics we do in statistics, this is the whole logic behind why are we doing this, because you say, well, why are we just changing numbers? A right skew distribution looks like this. And you might even see some sort of modality to it with negative check and balances and a right skew where you see like, here's where 0 is, and then here's the negative amounts. But we're going to see some sort of weirdness to the checking balance. Now, what you do a lot of times in statistics to normalize data is what's called a transformation. So our goal in statistics is to achieve a normal looking curve. We want to somehow achieve a normal distribution. It's just that a lot of the algorithms, whether it be, clustering, or we're doing support vector machine or other things, generally work better with normalized data, things that don't have extreme outliers, because then we're kind of fitting an algorithm to the outliers. So we want to somehow transform this into normal data. So with this in mind, and that does change context, we should say, and that's sometimes why we transform the values back to give it back to the original context of the data. So there's an issue, though. There's a huge, huge, huge issue. And this crazy huge issue is the following. It is right here. The big issue is right there directly on 0. Why is there a big issue on 0? Because let's look at some unique values on this. When we have 10 and we have 100, what is the log 10 of 10? And that would be red. What power do you raise 10 to? to get 10. Log 10 of 10 is what power do you raise 10 to get 10? What power do you raise 10 to get 10? Any ideas on what power do you raise 10 to? Like, what power would you raise 10 to get 10? And the answer is, who knows? Anyone know in the chat? Well, I'll write the next one while we do this right here. What power would you raise 10 to get 10? What power would you raise 10 to get 100? 1, you're exactly right. Great job. Another 1,000 points. Keep getting those points. You'd raise it to 1. What power would you raise 10 to get 100? 2. What power would you raise 10 to get 1? The answer is, am I doing this one correct? I'm thinking, wait. What power would you raise 10 to get 0? That's what it is. I've reversed it. I reversed it. Don't look at the last one. Oh, what's going on? Everything's going haywire. Uh-oh. What power would you raise 10 to get 0? And the answer for that one, no, I think I did it right. What power would you raise 10 to get 1? That is correct. I double guessed myself. What power would you raise 10 to get 1? You'd raise 10 to the 0. Does that make sense? So if you raise 10 to the 0, you get 1. Reading logs are weird. Read it with me. What power do you raise 10 to get 100? The answer is 2. What power do you raise 10 to get 1? As in saying, this would literally solve 10 raised to x equals 1. And the x is the answer right here. That's where x is. So that's where the answer is. It's weird. These are just, they sometimes like make my head turn sideways. So you'd raise 10 to the 0. So this is what power do you raise 10 to get 1? And you'd raise 10 to the 0. So with this in mind right here, we run into a weird problem. What we see is right here at 1 would be transformed. Let's put the transform value to 0. And am I doing correct? My brain's flipping. Yes, that is correct. That is correct. That is correct. And this one right here will be 1, and this will be 2. Now, what is so crazy about logs is this tiny space. I'm going to even make a new pen for this. We're going to call a UT orange pen for this. Might not be UT orange, but it's close enough. This space right here, that space going up to but not including 0 houses all the negative numbers. All the negative numbers. All negative numbers. Reason being is when you raise something like 10 to the negative 2, 10 to the negative 2 is 0.01. 10 to the negative 3 is 0.001. 10 to the negative a million is 0.00001. So all the negative numbers are housed there. You can't get to 0 doing this. It just doesn't work that way. So what are we going to do? We're going to do the following. We're literally going to take, and I wish I could just, I might be able to do it. Can I do it? We're going to take this whole distribution. Oh, it selected everything. That's a bummer. What I want to do is I want to take this whole distribution right here and shift it so that the lowest value right here is now over here. Because if I shift the whole distribution over, when I log it, that value will be then come what? Just think where it's at. Look at the green up above. When I shift the whole distribution over so that the lowest value is 1, then when I log it, I get what? If I shift the whole distribution over, then when I log it, so now the lowest value is 1, and when I log it, I'll get what? If I move the whole distribution over and do a shift of it, I would get, and I think they might have said in the chat, I would get 0. When I take the log of it, then I get 0. That's the whole theory behind this question. It's good we mentioned the theory and why are we doing this. It's to kind of actually get some, like, the lowest value is now 0 in the distribution, which kind of is logical to put it on like a log scale. So let's hop back over to the assignment and see how to do this. So these values right here have been manipulated this way, but I want you to think, you should know, looking at the values right here, I want you to tell me, what was this person's original balance? Look up in the original question and figure out what was that person, from what it says, what was their original balance? what was their original balance? Can anyone see what their original balance was? How much money did they have originally before we did all this transformation on it and shifted it and logged it and all this stuff right here? And actually, if you heard it, as you're thinking about this, think about what their original value should be when you solve this. I said shifted it and logged it. So we shifted it and logged it. So if we want to go backwards in time, you should be thinking this with me. Remember, we shifted it and we logged it. So now go backwards. We want to unlog it and unshift it. Do you hear what I said? We shifted it and then we logged it. So now we need to unlog it and unshift it. Does that make sense? So which one are we going to do first? We're going to unlog it. So remember from before, I don't know if we did this one. Excuse me. Excuse me. My mute button doesn't work on the screen. So here we are right here. Let's go 10 raised to the values. This is how you undo a log. You raise the elements, or you use the power of the log and do blank raised to whatever was logged. So now we have unlogged these. So now, remember we said if you take the log 10 of 1, it's 0. So now that we've unlogged them, we need to unshift them. And I need someone to help me in the chat to tell me, how would I unshift these? Remember, they were shifted and then logged. So now we're unlogging them and shifting them back to where they were. Well, remember what the original value needs to be, and that'll be a big help to you, because remember it says up above what we did to it. So what do we need to do to this now to unshift it? Because it was shifted then logged, so we unlogged it, and now we're unshifting it. We're unmoving it. And by shift, I mean you're moving it over in a direction. You're adding something to every element in the distribution. So what are we going to... super close. Super close. Still worth 1,000 points. Love the participation. It says right here that they added into it. So they added 513. So it says 513 was added to each balance. So 513 was added. So think, if we have something logged, we unlog it. If we added 513, what do you think we'll do to it? If we added 513, what do you think we'll do to it? If we added 513, how do we undo that? I think you'll know it from that. Because when we had something that's logged, we unlogged it. So if we added 513, we will subtract another 1,000 points. You're exactly right. We will subtract 513. And what should we see if we've done this properly? The lowest value in the distribution should be negative 512, and the answer is correct. You've done it. Great job. So you just think, okay, wait, someone added values to this. So they added values, and then they logged it. So I need to unlog it and then subtract those values. So you're just going backwards in time. It's like literally you're saying like add values, log, unlog, subtract values. You're just undoing what they did to it, if that makes sense. I know it's a little far away from the mic, but just think of it as reversing time on what was done to the numbers in here. And that's what we need to do. So no, great stuff right there. Does that help make a little more sense on why we're doing this? Yes, that's what I like to see in the chat. And so glad to have you here. Hopefully, I want this to grow every semester or every time we do it. But just talking it through and understanding, like, why are we doing this? Like, what's it mean? Could you give some advice for 8C on homework 1? Let's do this. I actually have to go set up SLC tonight. Yeah, sure. Yeah, great. No, ask the question. Definitely feel free to run. You can drop another question if you have it too while I'm doing this. Set it up. Have some fun. 8C, let's use the quick search. Here we go. That's awesome. If you notice, here's the name. You can just add your name to it. You can call it that. You can't have two chunks named the same name, but now it's called 8C Brian. So that's where it knows how to search. Once again, you can't have two chunks having the same name. Oh, I already did this one. Let's talk about it. Okay. So Lubridate is a super awesome package. Lubridate is a Hadley Wickham package. He's everyone's hero inside of R. Has made amazing packages that do advanced things that we did not have access to years ago. So one, make sure you have Lubridate turned on. Where is my Lubridate? Well, I guess I might have done it up here. We have library reg class. Well, we'll just put it inside of here. Okay, so you do need to make sure you have library Lubridate on, which I'm just typing reg class again, Lubridate. So here's Lubridate, and now Lubridate is currently working. So we have Lubridate on. And with that in mind, we should have fixed the data. So make sure you've done the fixing the data. If anyone has questions on that, feel free to ask. And let's take a look at what we got going on. It's important to know what we have step by step right here, so let's break it down. Those are basically the answers. What we have going on right here is we need to make sure, I'm going to go a little bit backwards on this because we need to make sure we have it right. With the by2 data frame, let's take a look at it. By2 data frame has buy box times. So let's look at the buy box times up here at the start. And with the buy box times, looking at the first 6 buy box times, we can kind of see the format to it. And the wrap on the screen is looking a little bit interesting right now, so we're going to make it look a little better if we can. It's really crazy right there. So here we go. Let's go right here. Let's do head. That's way better. Okay, good. Ignore the code. I think I was having fun last time with these. Okay. So what we need to do first, this is very big for when you do assignments or when you do the in-class coding. When you want to change a date format, you must first identify the date format. That's a huge note if you're taking notes on this. When you change a date format, you must first identify the date format. Well, I'm pretty sure 2018 is the year. I don't think there's a month or day 2018. I'm looking at this right here, and I'm saying, I bet 2018 is a year. Is there a month 10? Yeah, there's a month 10. Is there a month 11? Uh-oh. Wait, we got a problem here. The problem is that I can't quickly identify if this is the month. I can't identify if 10 is the month or if 11 is the month. One of those is the month. Now this is the hour, and this is the minute, and this is the second right here. So I know it's something like year, month, day, hour, minute, second, or it's year, day, month, hour, minute, second. It's one of those two. I can't tell. I mean, I know the answer, but I can't tell at this moment. Now, there's a few tricks we could do. We could just extend how many things we're printing. The function head gets you the start of a vector. It's just the head of a vector. Tail will get you the end of the vector. And 12, which is the second argument inside of here, tells us how many elements we're obtaining. So this literally says, give me the start of this vector, by2, $ buy box time, and give me the first 12 elements. Here's the first 12 elements to the vector, and what do we notice? Now there is no month 14, so this is definitely year. Let's go and talk about it. Year, month, day, hour, minute, second. And so you also see down here, it makes it clear by us printing out this one, which is given to you up above, that has to be October 19th, 2018 at 12:36 p.m. and 9 seconds. So we figured out that it is year, month, day, hour, minute, second. And I want to point something out. All of these functions inside of Lubridate show up, and they are pretty easy to use. All of these functions right here take a date format and turn it into a Lubridate element. It's position X or something. We can actually look at it here. We'll overwrite and we'll do that. And someone else actually showed this last time we were talking, and they have the as_date time. I don't understand how it works yet, but it worked, and I need to look into it more because I'm always learning new things. And it's a function I do not endorse because I don't know the ins and outs of it completely yet, but it did work. We checked last time to see if it was identical. It is identical, so it might work. I don't suggest using it yet. You can always teach me more things because there's always new functions. So what did we do with this? What did this line 269 do? What in the heck did line 269 do? Line 269 right here made it so that this is in year, month, day, hour, minute, second format. That's what it did to these times. So now if we go here and we run class, and class is something that BAS 320 is doing. It just tells you the class of something. And we go to page times. Page times has these kind of class to them. It's a position IXCT and position IXT, which is a date time format. So this is what we want it to be. We want it to be this class. That was the whole goal of it right there. So we've done it. That line of code has it properly formatted. Now that it is properly formatted, sorry, buddy. Now that it is properly formatted, we're going to go down here and we're going to go to bar plot, table, hours, and make our bar plot. Now, the important thing to know about a bar plot is the following. With the bar plot, it must take a table. So we're going to first run hour on by2, $ page time. And I didn't get my autocomplete. No, what is going on right here? Oh, I did something crazy. Let me fix this. I destroyed my code block on purpose, so we didn't see that code. Let's go right here. Little things can make big mistakes. Here we go, and let's go to page times. And with the page times right here, we're just going to see all the hours. So that's just all the hours of the page times. Let's turn it into a table here. So all we have is all the hours right there. Every hour someone went and visited this. Now we turn it into a table. That's just a table. You can see hour 0 to hour 23. And so that's pretty much midnight. And then we have up to 11 p.m. at night. And then we're going to go here and turn this into a bar plot. Bar plots take tables. So if you notice how I built that right there, that is so key. It's mad about my figure margins. We'll fix that. There we go. You can see some weird multimodal distribution going back to stat to 1 right here. There we go. So we see some multimodal distribution with just kind of peaks around like 5, 15. Here, I'll run it down below, or mine won't run down below anymore. Go zoom. So we've got this multimodal distribution with peaks around 5, 13, 21. And what's interesting, someone might have noticed, they might say, Brian, wait a minute. Can't you just make a histogram of that? The answer is yes. You can just go right here and do a hist of it because it is quantitative, and it'll look basically identical. Then you get the color options, which are pretty cool. You can color bar plot too. But it is quantitative. You could technically do that right here, do it in a histogram. Not everything else will work in a histogram because these will actually be more traditional bar plots. Let's see it right here. The month bar plot is going to look the following way. And you can't make this into a histogram because it's not quantitative. We're doing a little stat to a 1 again. This is traditionally a bar plot right here. It's weird to say you can make a bar plot of hours, but you can say what hour was it. But hour is also quantitative. In truth, you might want to treat it more like a histogram. It kind of makes more logical sense. But you can always do like the hours that were 1, and it's like group 1, and so it works as a bar plot too, but it is more quantitative data than it is categorical. But you can't treat month. I guess you can do month as a histogram because month 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and you could do day as a histogram. And so I wouldn't suggest doing that, but let's just try it. Let's go here and let's go here to month, and if we don't have labels on, yeah, there it is right there. And without labels on, and probably once we put labels on this, because we're going to add an extra argument, we're going to go labels equals true. And now it should get mad. And you see it says it must be numeric because it can't take non-numeric for the histogram. Histograms require quantitative data. And if we treat months like month 1, month 2, month 3, month 4, which you can kind of do because it's like how far are they apart? Like month 1 is 2 months away from month 3. So you can use it as a quantitative data. But you can't add the label because that turns it into a word. And that is what we're seeing right here. If you look at the histogram behind me, now I've turned it back into a bar plot because bar plots have categories. So this right here can't be a histogram because it has words on it. And you can't make a histogram from things that have like names because it's not a quantitative thing. But treating them as numeric, you can make your histogram. So kind of the nuances of when do we use histograms, when do we use bar plots. Histograms are for quantitative data, univariate quantitative data, and bar plots are for univariate categorical data. So kind of the like small subtle differences. They're very close to identical. They just put things into bins, and you'll notice that the graphics are virtually identical. They're just calling it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and January through December. I thought I would say them all there. But this is how to do this one right here. You might wonder why we do label equals true. Well, days of the week can have labels, months can have labels, but you could do something like right here. You could make a histogram of year. So what's so awesome about Lubridate is it'll actually do it completely for you, and it might make more sense. Looking at this graphic right here, year is quantitative, but I don't like the way this has 2018 and 2019 with all the numbers between. So when you think about this, is if you grab this right here and you run the same code and you go here and change this to year, I think this looks a lot better when you talk about year. You have like 2018 and 2019. And if you compare, I think this might bring us back. It doesn't keep the graphic open. But if you compare this right here to this, I think the bar plot looks a lot better because it makes more sense. It's like you can ask it in the way like, what year did they buy it? And if you just want like a bar plot, you're kind of asking what, or you could say like, how many years is it? I think we've had 2018 years because quantitative is always how much, and years are quantitative because you can do the years between 2016 and 2019. But Lubridate is so awesome because you can even pull from here the seconds. I'm going to investigate some stuff. Feel free to ask a question, 201 related, 320 related, 474, any statistics question. If you came across this video and you're like, hey, I want some help with some stats, well, that's what we're here to do. Seconds have a pretty uniform distribution. If we're thinking about when did they grab the time for this, there's a little bit of less right here and a little more here, which is interesting. Somehow they were like not grabbing it at the very last moment, but maybe when the 60th second completed, maybe they're putting it here. It's a little more. It almost looks like it's losing a fifth. Like this has 1/5 more and this has 1/5 less, which is kind of interesting since the bin widths are 5. So that looks pretty uniform to me. This is about, truthfully, that's about the best uniform distribution I've seen in a long time from real data. So let's change second to, I think we looked at hour. Let's look at minute. And minute is also very uniform. Uniform distribution is just a flat distribution. Don't look at this and say this is a peak and this is a peak. It's random. Pretty random right there. And if you notice, all I'm changing is one argument right here. I'm just changing this from minute to hour. Hour is where we start to see the interesting stuff. So now we're seeing at what hour was this data taken, and the data was taken at those primary times right there, telling us that some reason they were scraping at those times. When we go up from hour, we're going to day. You can do day and without a label. This is day of the month right here if you look at it. So we do see that 31 does not have as many days scraped. Why would 31? Because not all months have 31 days. So they did not scrape as often right there. And I think they scraped for 3 months. So it looks like they started 2/3 the way into 1 month and they ended 2/3 the way through another month. We can actually find this out by doing a summary of page times. And the summary will show us when they started and when they ended. So I've got it in here twice, is all right. They started on October 11th. And then they ended on January 11th. So it seems to me they went October to November to December to January. They did exactly 3 months, as best we can do 3 months. That's why the days look pretty uniform. And 31 would only come from, so there wouldn't be a 31 for January. There'd be a 31 October, has 31 days, obviously. November is 31, also December 30. I know that the knuckle trick up to a certain amount where you do January, February, March, April. And then December has 31. So maybe they just didn't scrape as much on the 31st. It looks a little lower than I would have expected, even though they didn't get a January for the 3 months. So pretty interesting right there. I'm trying to think what else to talk about on this. So there's the daily. You can type in Y day. This is why Looper Day is so awesome. There's the days of the year they scraped, which is actually what we were saying, is that they started towards the end of the year right here. They started in October 11th right there. So that's where October 11th starts. Then they went all the way back around to January 2019. So it's kind of important to see what's going on right here with the data. And so now we have year day, and we didn't do weekday. W day is weekday. So there's another function right there. Might look better in a bar plot. That's why I wouldn't use this. But if you do a bar plot, you have to do a table. So we're going to put this inside of a table right here. We already had the function around it once. And then inside of the table, we need to do this, sorry. We want weekday, and we're going to go right here, and we're going to go table of this and turn this into a table. So bar plots take tables. I'm going to do it the right way. We're going to take weekday, turn weekday into a table. And with weekday turned into a table, here we are right here. We're going to go here inside of weekday, and that's what I wanted to do, and put the label equals true. So if you notice, page times, comma, label, and it'll come up true. Now my table down below will actually have the names of the days on it, and you see the switch right there. And if you want, you can take this and turn this into a bar plot. And if you're wondering, if you're like, man, this is too much code, I just want to call this X. We're just going to call it X for the moment, and then we're going to do bar plot of X, and there's the bar plot of it. So you can kind of do an intermediate stage. You can kind of say like, okay, wait, I just want to, for a moment, I'm just going to stop here. I'm just going to save it as X, and then I'm going to do a bar plot of that. And what's kind of nice, you could just change this now. You could change from weekday to month. And so you can change that to month, and you can just make your month bar plot like that. That's basically what we have going on right here. But so much fun with that. And I bet I won't do that. I was going to do another function. Are there any questions in the chat? How's everyone doing with questions right now? how many people do we have watching? And 474, 201, 320. If you have questions, feel free to ask them. Let's see over here. We'll look at the analytics. If you have questions, feel free to ask the questions. Might do a little more right here. I figure when we get closer to the test time, people will be coming in here. And the homework is due tomorrow for 474. So if you have questions, feel free to ask. Let's see. What did we do? Let's talk about 201 a little bit right here. So with 201, we talked about a lot of great topics this week. We talked the last bit here about, and feel free to ask a question if you have it, the topics we talked about for the last little bit right here are going to be, let me go down to here. Okay, let's open a new spreadsheet, our new workbook. We talked about distributions and when to use certain types of displays. So we have right here stacked histograms. Now a histogram is just a quantitative display of data. So it's important to know that histograms are quantitative, but then if we do stacked histograms incorporate two variables. This is the key right here. When we have stacked histograms, we have here two variables. This is like the big difference right here. A stacked histogram is when we have two histograms stacked on top of each other. So a histogram is still quantitative, but what we're incorporating here is two categories, like male and female, or like freshman, sophomore, junior, senior. We could do a whole bunch of stacked histograms right here, but we just have here histograms stacked on top of each other right there. So we could do dog and cat lovers right here. We'll go dog people, cat people, and you have two different groups. So this is where the variable right here is categorical. So I'm going to put a C right here. It's not that the histogram is categorical. Maybe we're looking at pet expense. So we want to ask, how much do you pay for your pet? Do you own a dog or a cat? And we'll only get people who own like one dog, one cat. So we can kind of keep it like standardized. We want to say like, well, what generally costs more, a dog or a cat? So we get only people who own one dog or one cat. And then we ask them, how much do you pay for your pet a year? And we might not see something like this. It's rather interesting. Which of those, we have 3 people watching, 1,000 points in the chat. If someone says, which of those do you think costs more, a dog or a cat? Which of those would cost more, a dog or a cat? Any ideas? Who's got a guess? Got some high spenders right there. And then we'll draw this distribution here. We'll say how much people are spending a year on dog versus cat. I think dogs would eat more. That's my assumption right there. Dogs would eat more. So I'm going to say a dog costs more because I like dogs more. And let's go right here. This is the dog distribution right here. This is the cat distribution. And we ask people, how much are you paying for your pet a year? So you see right here, we have two distributions. The amount people are paying for their dog, the amount people are paying for their cat. And we would draw this line underneath this one and this line underneath this one. And this is 0, this is 0. And this goes all the way up to, let's say, $5,000. Or no, let's go, not 5,000, let's go 10,000. There was a surgery. So this was a pretty major surgery right here, which is interesting. We might actually see some modality on it for the animals that need a certain surgery. And so this would actually go all the way to 10,000 also. We keep the axes the same. So we put them on the same common axis so we can kind of compare apples to apples. And this would also go to 10,000. You can see both of these distributions are skewed. Like generally there's a pet cost on average, or we probably would use median here thanks to the heavy skew. So when we're comparing this right here, we're comparing people who own one dog or one cat. So that's a category, like do you own one dog or do you own one cat? Like which group do you belong to? And then we would have right here the amount you spend, which maybe the dog people are out spending on average. We'll go to the median of it. The median might be right about here. So the mean is going to be a little higher. And then this one might have a mean of about here, a median, excuse me. And this is where the mean is at. So let's put a red X for the mean. The mean is going to follow the skew, kind of good review topics. And the median is the 50th percentile, which means if I were to shade in the bottom portion of this, that should be 50% right there. and this should be 50% of the curve. Like 50% of people spend the median or less. So we're going to write down below here median, and then we're going to write the other color, mean. And the biggest thing is the mean really tells you which way the skew is going. So you can see at the median, which could be a value like $5,000, that's pretty expensive right there, but these are really nice show dogs. So the average person, the median person, spends $5,000 or less, but due to the skew of the distribution, the mean is being pulled up, where maybe cats have on average like 2,500 or 3,000, wherever that median is, the middle value, which is going to give us an idea of kind of what we would expect the 50th percentile to be. The 50th percentile of people who own cats spend this much on their cats. So that's what we have going on right there. That is stacked histograms. Now, another display you can make that is very similar to this is side-by-side box plots. We can kind of draw this out to say what that would look like. We can draw a box plot here for the cat individuals, and it's got a right skew to it. So we're going to pull this way, and then we're going to put a little lesser down here, and then we're going to put the median, and then our dog people are going to be more skewed or have a higher mean and median. So they're going to be up here, and then be like this. It is harder to notice, and we've got, here we go, cat and dog. And if we were to show the axis right here for this one, the axis for this one's going to go somewhere like 0-ish up to 10,000. And we can see both kind of distributions right here. If you notice, if I'm going to point to a spot on this with like an arrow, this spot right here is the maximum, which is the maximum there. So that's the maximum right there. And if you go to the dog distribution, you would say this is the maximum right here, and this is the maximum. Apparently there's no outliers, at least the way I drew this, because we don't have anything 1.5 IQRs above Q3 or anything 1.5 IQRs below Q1. But what we've kind of done here is we've come up with an idea of what this is displaying. This is displaying a categorical and a quantitative variable. Now, box plots by themselves display quantitative variables. One quantitative variable, they're univariate quantitative. But side-by-side box plots will take the categories. So now we have cat people and we have dog people, and we're just talking about how much do they spend. So the box plot's displaying for us how much do these people spend on their pets, and then the categories are cat and dog, so that just breaks apart into different box plots. So side-by-side box plots are basically doing multiple box plots, and stacked histograms are basically doing multiple histograms. Okay. Let's try another thing right here. Let's think of another topic that we can talk about from this week, because I might try to like snip these videos out and talk about them here. So what do we have as another good review topic? If someone has a question in the chat, feel free to say it. Be like, Brian, I don't know how to do this. How do we solve this? And we will solve it. I'm trying to think. We're right about to do pivot tables and pivot charts, and that's a lot of fun. So maybe I'll do a quick video on that. Okay, let's open up Excel. Let me go grab the data for it. So we're going to go grab the data, and let's grab the data. If you have a question, if you're watching right now, feel free to put your question in the chat, and let's go in here and let's grab that 201 data. Let's go here to modules, and let's grab the pivot table data, and let's do it. Okay, we got the pivot table data open. So let's take a look at this data. Let me get my chats back open. Okay, so let's go right here. Okay, so now that we have some data inside of Excel, there's quite a few things to know. Let's start. You ready? Now that we have some data inside of Excel, there's a few things we should know about it. First off, you'll notice that it has the column names at the top. You'll see these right here. These are just all different column names. Next, we see that everything's been entered the same way. Male, female has been entered the same way. Sophomore, junior, all these are all entered the same way. That is very important for how we will be analyzing data for doing the pivot table. So to make our pivot table, what we will do is we will go here to first hit Control A or Command A. If you're on a Mac, you'll want to hit Command A, but this selects all the data. There's other ways of doing it, but I like to select all the data with Control A or Command A. Now that we have all the data selected, let's go here to Insert and go to Pivot Table. So now you'll notice it has everything filled out for us properly. We can insert our pivot table and let's click OK. We actually are making a pivot table right now, even though it doesn't show up. So with the pivot table on the screen, we need to first figure out what are we going to display. So I'm going to bring this over here so we can see it. It's very small right now, but you'll notice this says values right here. This is the value we are going to display in the pivot table, and it's the first thing we should figure out. Like maybe, let's say I want to look at people's class levels. Well, I'm going to put class level here. So with class level dropped in, we see here in the pivot table the count of class levels. Now, maybe that's what you want, maybe that's what you don't want. But at this point, we're just figuring out how many people answered the question class level, which was freshman, sophomore, junior, senior, fifth year, and I think non-traditional. But let's do something extra. Let's take class level and also put it into the rows. Now you'll notice, and we'll need to bring this down a little bit, that we now can see the different levels, and we can see what the answers were. We can see that 9 people were fifth year plus. We had 209 freshmen. Something important here that we see is that this is all out of order. So we're going to click here. This is where we have to be very careful, and we're going to drag this up to the top. We probably want freshmen first. Fifth year seniors, we're going to grab this, and we're going to drag this down right here. We're going to grab non-traditional. I'm grabbing right there. If you pause and look at what it should look like, it should look just like that. And you see you have to click it just perfectly. It always tricks me. Let's go right here and grab this one and bring it right there. There we go. Now we can see the distribution of freshman, junior, sophomore. Oh, we got one wrong. I was like, that didn't sound right. Grab and bring right there. Now we can see the distribution of freshman, sophomore, junior, senior, fifth year senior, and non-traditional student. So we've ordered this correctly, and definitely figuring out how you want to display your data is very important. Like make your data look nice, and that way people can understand, because this is a logical ordering right here. So now we need to figure out how we want to view it. Let's go over here to the pivot chart. The pivot chart's going to choose some default options for it. We can choose among this and choose other things, but we're going to click OK for the moment. And look at what we get. Pivot chart. Everything you saw previously is now being displayed in a chart for you to see, and there's tons of great options. We're pretty much right to making our graphic that we want. Let's go here to design on the pivot chart, and let's go to quick layout. My favorite one is the following one. We'll have to do a little resizing here in a moment. We're going to resize this, and we're going to make this go away over here. We're still going to keep it, but we're just going to make it very small for the moment. So we need to get everything nice and great. There we go. All the text is not kind of wrapping around now. You want to make sure someone can actually read what it says. We don't want, let's look at the bad version again. We don't want the text to, that is ridiculous. Don't turn that in. Don't do that. That's horrible. So we want it to look something presentable. We want to be like, looks good. We do not have an access title down here. I'd probably put one in. This should probably say something like class. So we're going to go and click this plus icon. The plus icon has all of your options for the pivot table, the pivot chart. So we're going to go to access titles, and you notice you have to go to a sub menu, and we're going to add in the primary horizontal. I'm going to change this to class level here. So let's go this to class level. And we have class level. This is just the count of individuals. So let's go here and go to count of individuals. So that's the count of individuals, and then we're going to exit out of this. And then we're going to go over here, and we're going to say, it really likes to bring up that menu. We're going to say analysis. Let's say, how do you spell analysis? Analysis of class level. There we go right there, analysis of class level. We've got it. And there's our graphic. Just depends on what we want to call it. Different assignments might ask for you to call it different things, but this is an analysis of class level. We might want to get more specific, like where was it taken, who was it sampled from, but for right now, we're just going to leave some pretty basic titles. And depends, I will say this, there are tons of options on what you can do. It really comes down to your own preferences and what would look professional in your setting. There's so many kind of cool ones, but you got to watch out. Like sometimes a cool one can be a little too much. But that's it. That looks like old school, like computer to me right there. I kind of like it. But maybe people in your industry might not. So you might go more traditional. We usually don't go 3D. Actually, this one right here, it's got a nice like texture to it. And it's really got a good outline on it. You notice we also have the amount of individuals, and I'm going to do a little more cleaning up on this. I didn't like how that was kind of touching this right here. I will say this, if you copy paste these pictures into Word, they still have the interaction from from Excel, because Excel and Word are both Microsoft products. So if you copy this into a Word document, you still have the interactivity of it. Sometimes I like to take a screenshot of it using Snipping Tool or Command-Shift-4 on a Mac. That way I have like a static just element that doesn't change. So you maybe want the ability to change it, then copy paste it in, or maybe you want it to just be a picture, so then you can just take a screenshot of it and do what additional editing you want to it in something like Photoshop. Now this is just a univariate analysis. It's just kind of what class level people are. We could look at class level by something like, were you born in Tennessee? So let's put that right here. And if you notice now we have a bivariate analysis, and we probably want to make sure it looks really great right here. Looks like our words are pretty decent there. I'm going to pull this up a little bit there. Looks even better now. So you notice I don't like when the count of individuals kind of goes off the screen a little bit or touches the other elements. And now we'll do by born in TN. So right here we've kind of extended our title to be class of individuals or analysis of class level by born in Tennessee. And you can see the differences. Not too many key differences, nothing really fun and crazy here, but you'll see here there's a lot of sophomores. It's generally a 2-to-1 or 3-to-1 ratio. I guess freshmen have a 3-to-1 ratio. Sophomores have a 2-to-1, and this is a 1 to 1.5 ratio, pretty even across there. So I guess you would say we see the most drastic differences among freshmen, that freshmen have 62 not from Tennessee and 147 from Tennessee, and then the differences kind of get smaller in terms of a ratio, because this is the highest ratio difference of the two, and then we see less of a ratio difference. So it's almost equal, but those are small sample sizes. We actually see more seniors who are in Tennessee, and it's very close, but it's a close call. Once again, a smaller sample size. We could try something pretty interesting here. We could go to using tobacco. Now I'm going to put this here for a second, but I'm going to remove it. That is way too much information on one graphic. We're going to go here to see if there's something about using tobacco and being born in Tennessee. So in high school, so we'll say tobacco in high school. So that is tobacco in high school by born in Tennessee. Not too big of differences. We see 47 to 102. It's a 1 to 2 ratio almost, I'd say still. So nothing too crazy right there. Let's think of something crazy. Let's do something like here. Trying to think of another really good question. Pepsi or Coke? Pepsi or Coke? Let's get controversial right here. Let's go. Oh no! And actually, I was not displaying the right thing in here because I still had count of class level. It's interesting. I think it will actually display it still. Use tobacco in high school, and it does display it properly because it's just getting the counts from these right here, so it's going to actually display it properly, which is interesting. I've always found that interesting about pivot charts and pivot tables. So we are displaying the right variable right here, but we should probably change it out between the two right there to get the proper variable to be displayed. But if you can't tell, this is why we use pivot tables and pivot charts, is because they're really easy to make graphics with, and a lot of people have access to Excel. Excel is pretty much on most company computers. It's a program that's easier to learn, doesn't require coding backgrounds, and you learn it generally at an earlier age. So we try to teach pivot tables and pivot charts to help you out understanding these topics and getting a good idea of what's going on with them. So knowing where the options are at and knowing what's going on. Let's do one last thing with this though. Let's say we want to filter out some values because that's the only field down here we really haven't talked about. Like let's say we don't want to include seniors. So if we want to go over here and we want to go to class level, we're going to include that in the filter. If you notice, we've got this filter up here and also on our other one, and we can say let's not include seniors. So we're going to go here and remove seniors, and the graphic will change. So you've got all these great options to maybe you don't want a certain variable or a certain level of variable in here. You don't want people who have tons and tons of shoes. Let's go here. I think someone reported there's a number of shoes someone owns, pairs of shoes. And let's go here to pairs of shoes. Someone reported owning 127 shoes. So you might think maybe these are not true values, so you can remove them from the data set and create a filter on this. So all of these options are available to you inside of Excel. So we can filter out things we don't want. If we didn't want seniors, we can remove them. If we think a value is too high, we can remove it. Once again, don't just toss out outliers because you don't like them. You need a good reason, and then you should do the analysis with and without the outlier. But if you have some way you want to limit your analysis, you can always do that here with the filter options, which pretty much covers everything. We covered kind of what the access and the legend do. They just separate your variables. The value is what value is being displayed, and there are options here. You can go right here to value field setting. we could drastically change this. Let's go right here and remove the value being displayed and go to high school GPA. I'm putting high school GPA in this, and this now has the sum of all the high school GPAs. It's a little hard to see, so I'll bring the screen over so you can see it. But right here it says sum of high school GPAs. I don't want to look at the sum maybe. I want to look at the mean, and we need to go to the value field setting right behind my shoulder right there, the value field setting. So let's go to value field setting and not use sum, but use average, which is the mean. Now we're looking at the average GPAs for this group. This is where having the right value really comes into play. We also have some crazy decimals going on right here. Let's fix those crazy decimals. We're going to go right here. We're going to click the number, and then we're going to go to the delete decimal button. Actually, you have to fix it over here. So we're going to move our chart away for a second. We're going to move this over a little more. We're going to go back to these cells, and we're going to click on the one and then hold shift and click on the last one. So we clicked on the first cell, just click on it, hold shift, click on the last cell, and then delete the decimals. That just kind of removes them off the screen, and we're just going to reduce down to 2 decimals. When you say your GPA, you don't usually say 3.78482828. Someone's like, calm down. And let's hop back over here and take a look at our graphic. I think this graphic could be a little smaller now. That looks pretty good right there. And so if you were looking to take a screenshot of it, I do like static images a lot of times. If I'm going to put them in something, I just want it to be a static image. I'd probably take a static image like that right there. That would just drop into a report. If you do copy paste it out of Excel, then into Word, you will get a dynamic image, which can be changed. It's actually linked to Excel. So if you change it in Excel, it'll change in Word. It's good and it's bad. You got to watch out, because if you were to make all your graphics and change it each time, then the graphic linked will change. So you have to be careful. I've done that before. I've been like, wait a minute, I changed my graphic and it changed it. So really great options right here. I like taking my own screenshots. That way I kind of like, this is exactly what I want to see on the graphic. But that's got it. We see now the high school GPAs. We've got class level down here right now, which this needs to be no longer class level. Let's change it. So this is going to be, I think down here we have whether or not someone uses tobacco. This is used tobacco in high school. So tobacco in high school. So that's used tobacco in high school right there. And this is if they're born in Tennessee or not born in Tennessee. You'll notice there's really not much of a difference between the born in Tennessee, not born in Tennessee. And I was hoping we'd kind of select the groups, but we can see right over here a little easier whether or not people were born in Tennessee and whether or not they used tobacco. So all of this right here is being displayed in the chart and in the table that we can see. So the highest GPAs were people who don't use tobacco and who were born in Tennessee. They're very close to the next one, which are people who don't use tobacco and were not born in Tennessee. So this is don't use tobacco, not born in Tennessee. And this is people who were used tobacco, not born in Tennessee. And you can see it right here. That's their average right there. And these are the people who used tobacco and were born in Tennessee. And this is tobacco in high school. This is specifically tobacco in high school. Just different variables collected on right here. And it doesn't mean that you will have this GPA because we can change this. Let's go to the value field setting and click right here. It's just that little, let me show it off again. I'm clicking this button. It's hard to see, but it's a little tab right here, and it's going to bring up value field setting. Let's look at the maximum value on this. And these are the people with the highest GPAs in these groups. And you'll see there are some very high GPAs, much higher than my GPA. And so we see a 4.86, 4.78, very high GPAs, 4.30, 4.42. You can look at the minimum values on these. We just go here and we change it to minimum and minimum values. So we see a 1.10, 1.80, 2.0, different values right there. Can we pull up the median? I'd like to see the median. I think these are right skew distributions, so the median would make more sense. Does Excel give us the median? Oh, that is not fair. It does not give us the median. Little sad there that we don't get to do the median, and I don't know why Excel doesn't have the median for us to display. Median is much better display for skewed data, and high school GPA is generally a skewed distribution. So sum is kind of ridiculous because then we're just adding together people's high school GPAs. The reason this group is so much higher is because there's more observations in this group. It's not because the GPAs are the highest. It's also coincidental that they are, but it's that there's more GPAs in that group for us to take from. So we're just adding together 3.0s, 4.0s, and this would not be a good display of data. It's not conveying any information. It's like the sum of everyone's GPAs in these groups. Well, it's like we don't do that with GPAs. We don't add together my GPA and your GPA. I'd wish that, then I'd have a 4.0 maybe. So we would sum all those together right there. You could do the range, the product, all these fun things. I thought I saw range. But that's got how to do the pivot tables and pivot charts. Good information on that. So might try to do a topic or two more. But is anyone here? Do we have some people with some questions? You can always ask the questions if you're watching and be like, hey, Brian, I have a question. I am stuck on this assignment. How do I do this? Ask any question you have. We can use jump. We can use R. So if you have a question, feel free to ask. Let's see. Might do one more topic and then get a little food before meeting right here. So let's hop over and let's see. I think one of the big things is especially knowing how to use jump, just a little bit of practice and seeing what we can do. So let's talk over some basic displays in jump and see how we can do a basic display or two. Some of the basic displays in jump can be done with analyze distribution or analyze fit y by x. So let's go here to analyze distribution. Now you'll notice you get here red and blue. The blue is quantitative and the red is categorical. You can actually limit what you're seeing by going here and removing the numeric or removing the character, which there they go, they're gone. Characters are the categoricals. And let's put them back in the numeric and we get everything back in here. So now we're going to analyze age. But I want you to think for a moment. Age is quantitative, and we're going to make a visualization of a quantitative display. We should see things like stem and leaves, histograms, box plots, and dot plots. And there might be a way to make a dot plot inside of R, I believe, with Graph Builder, but we won't see that one yet, or at least not now. We're going to stack it. It just makes it easier to see, and this is our basic quantitative display inside of Jump. With this quantitative display inside of Jump right here, we can add summary statistics if we like, just by customizing it. Maybe you want to know the skewness. Maybe you want to know the interquartile range. Go down here and click OK, and what do we see? We see the skewness right here is 9, which, one, we should know that if it's a positive skew, that means it's skewed to the right. So that's right skew, and we sometimes call that positive skew, and that's a positive number. You can see the extreme right skew on this right here because, well, look at that. It is just extremely pulled out to the right. So right to the high, left to the low, whatever way the tail goes. So the tail is going out to the right, which indicates positive skew. You would never find that skewness by hand, or at least I wouldn't. But it's nice that the software can give you a number on it. You'll notice we do have added here the interquartile range because we have here 20 is the Q3 and 19 is the Q1. So 20 minus 19 is 1. It makes for an interesting box plot. If you're following along or watching this, then what do you think the whiskers have their length of? The maximum length the whiskers could be is 1.5, but we might not have observations there, so it does look like the whiskers have length 1 because they look as long as the box, and the box right here has a length of 1 because the length of the box is the length of the IQR. So I think people didn't answer the half ages, so we just didn't have an observation right there. And we can actually confirm this. Kind of cool thing we can do right here. One of my favorite options in Jump is doing the automatic recalc, and we can make it so that it's interactive with the data we have behind here. So we're going to put this over here to the side, and we're going to watch what happens as we change someone from 19. Let's bring the data so we can see everything going on right here. We're going to put the data right here, and we're going to change this person to an age that would make it so that they would be at the very end of the whisker. We can choose anybody right here. So we're going to choose an individual who is, oh, it put it on both screens right here. We didn't want that. There we go. And let's move it. Don't try to auto. There we go, good. So we have here a 19-year-old, and we're going to change it so that they are, and think of where the fence would go to. It'd be 1.5 above Q3. Q3 is 20 right here. So it'd be at 21.5. So what we should see is we should see this go up right here. This is where we have 21, and let's make it 21.5. And we should see that whisker go up just slightly. Did you see it? It did it. So that shows that that is where the fence is. Now watch when I change this to 21.6, they became an outlier because 21.5 is 1.5 IQRs above Q3. Q3 was 20, and so we went 1.5 IQRs, which is 1.5, because an IQR was 1 for this, and then we went 1.5 up, which is 21.5, and that is the maximum value that would be to where the whisker would go. But we don't have values there. We have values like 21. And if you notice, that's where it is at. If you think about where this fence goes to, this fence would go down 1.5 IQRs below Q1. Q1 is 19, so it would go down to 17.5. That's why 17 right here is an outlier, because it's more than 1.5 IQRs below Q1. But if we change this to 17.5, let's show the graphic while we do it. If we change this value right here to 17.5, watch what happens. 17.5 is the lowest value that is not an outlier. So you'll see the whisker go down a little bit further. Did you see it? The whisker moved down just a little bit. But now, if I change it to 17.4, that's outside where the fence would be. So now 17.4 will be an outlier. Also, you notice the whisker moved back because there's no data there. That point changed and there is no 17.5 value. So the whiskers only go up to the value that is the largest or the smallest within the fences. And we can do another example. This was a big question this week. Let's do one more example of this with a new data frame here. So we're going to do a new data frame. Let me open the Word document in the background so we can get a nice blank page behind us. And we can just focus in on this right here. So let's put in some values right here, and let's just call this data. So we're just going to call this data. And we're going to enter in 1, 1, 1, 2, 2, 2, 3, 3, 4, 5, 8. That's not an 8. That's an 8. And 10. This is a pretty right skew data set. If you notice, it's got a lot of small numbers, and the tail would go out here. It's not just, you'll see in a moment, it's not just because I'm going in that direction, but you'll see it's right skew, and there it is. So this is a right skew data frame right here. You can see the buildup of the 1s, of the 2s, of the 3s that I wrote, the multiple 3s, the 4, the 5s, the 6, the 8, and the 10 right there. So it's a right skew data set. And let's take a look at what we have and why is 10 not an outlier. So we did get a nice, we'll change this. Let's add in another number right here because I want some nice data. It's easier to work with when the data is nice. So we're going to hit redo. Oops, not redo. We want automatic recalc. Let's go to automatic recalc right here. Let's add in another 10. Why not? No, I'll add in a 3. There we go. We still have a bit of an interest. Oh, that's 13. And let's add in 4. Perfect. I like this data. Let me explain why I like this data. I like this data because the IQR is going to be easy to calculate. And then on top of that, it's going to be pretty easy to figure out what is 1.5 IQRs. So when we look at the IQR is Q3 minus Q1. The IQR is 5 minus 2. So the IQR is 3. Oh, yeah, let's do that, Ivy. We'll do that next. And I'm going to explain this briefly here, and then we'll go right to that. So the IQR is 3. So think about where the fence would be. It'd be 1.5 IQRs above 5. So it would be 3 times 1.5 plus 5. And so with that right here, and let me write it in the background. So remember the IQR, oops, we got highlighter on. So IQR, we'll go to green, it's a much nicer color. IQR equals Q3 minus Q1, which is 5 minus 2, and then that equals 3. And then the upper fence is going to be Q3 plus 1.5 IQRs. So when we do this right here, what do we get? We'll write it in orange right here. This will be 5 because that's the Q3 plus 1.5 times 3, which is going to equal to, I'm doing it in my head, so hopefully I don't make a mistake. It'll equal to 9.5. Not the hardest of math, but sometimes you make a mistake. So we can confirm that we are correct right here. That's what we like to do. We can confirm that we are correct by going back and seeing what happens when we change our data. Let's take this outlier of 10 right here and move it right to 9.5. Now, if 9.5 is the upper fence, we're going to see that whisker move and that outlier disappear. And we did. Now, if we go here to 9.5 and we change it just barely to 9.5.01 right here, it is an outlier. So once again, 9.5 is the exact highest number it can go to. If you notice, the whisker no longer goes out that far because it now goes up to 8. Notice how you can trace that down. 8 is the highest value that is not an outlier. And now 9.501 is an outlier, but if it was right on the fence, it would not be an outlier. Very, very small difference right there. That's how the calculations are done. Let's hop back into R here, and let's take a look. Okay. Can you go over question 1 for homework 2? Yeah, sure. Let's do that. I got homework 2 up here. Okay. Okay, let's take a look. Question 1. Is it this one right here, Ivy? Is this the one? Confirm yes or no. Like, does this look to be the right one? We'll find out in a moment. I believe so. So we're going to do some for loops right now. Fun with for loops. So we see right here we have a vector of 5.5 comma 8.6. We have 2 elements in this vector. So this is just a very small 2-element vector. And then we've got a tedious way of doing this. So we could store into the third element, read these as a sentence. I want to store into the third element of x, which is going to put a new element right here. It's basically going to store some sort of number right there, which we'll be doing right here. Store into the third element of x this equation. All this is an equation. You can highlight this and run it. That's just an equation. So when you think about this, when I run this line of code, it's going to take, and then x will have another element in it. It'll have a third element, and that third element is what you just saw me run. The next line of code says store into the fourth element of x, so it's going to put another element on x, store into it the equation, and we see it right there. Now here's the thing. You'll notice there's a pretty interesting pattern to this. So what do we have? What is the pattern? What is going on right here? Well, it needs to repeat all the way to 500. Now I asked this with the way to do it. Now let's slow down. This is huge help for this question. When you write a for loop, I wish we had everyone here in the chat. I wish this was like online. I'd be like, when you write a for loop, do not write a for loop. Do not write a for loop. And we've done a lot of the work on this question of not writing the for loop for you. Because when you write a for loop, you first write your skeleton. And what do I mean by skeleton? Skeleton is just the inside of a code. It's the inside of a for loop. Let's take a look at a skeleton here. So we're going to go for, and we're going to make our skeleton. Our skeleton is just going to be, let's say, print. And let's go here to print I. So we're just going to print I. That is my code. That's my skeleton. I'm going to go here to the variable name is I. That's just what I called it. And I is going to go 1 through 10. What did it do? It printed 1 through 10 for me. That is what the code does. The code prints 1 through 10. This code will never change. And I'm going to allude to one of the later questions here, because what is my code actually doing? Well, every time it runs, it literally prints I. The inside of my code is just printing I every time. But here's what does change. I changes. So the first time it runs, I is equal to 1. And we'll change this right here. We'll do it 4 times. That way I can write less. And I can kind of keep it on the screen. I is equal to 1. Then the next time it runs, I is equal to 3 or 2. And then I is equal to 3. And then I is equal to 4. So if you notice the code I've written here, both sets of code do the exact same thing. This code right here, what does it do? It prints 1 through 4. This code prints 1, 2, 3, 4. Notice here, I want to point something out. This is the skeleton. The skeleton does not change. Does not change. So let's make a skeleton. You ready to make a skeleton with me? Let's do it. So we need to grab one of these and turn it into a skeleton. So let's grab this right here, and let's think about it. So to make this into a skeleton, we need to add some eyes in here. Okay, how are we going to do this? Well, an eye can be anything. It could be called Brian. Sometimes I call it Brian in class. And what do I mean? Like, just want to point out what I mean by eye can be anything. Like, this could have been called Brian. And then Brian is just the placeholder for what changes. So now when I run this, it does the same thing. It just changes what Brian is. So that's just a placeholder. We oftentimes use I because it's short, and it oftentimes means position or the ith element, but it can be anything you want it to be. You can call it Brian. You can call it your name. You can call it New York. It doesn't matter. So with all this right here, we need to pull in some I's. We need to pull in some sort of name for these that will change. Well, Ivy, I need you to take your pick right here. Do you want to call, which one of these do you want to call I? Do you want to call 3, 2, 1, 2, or 3 I? Which of those do you want to call I? Because I'm going to call one of them I to turn this into a skeleton here. Which of those should be I? Any idea? There's a few of them I would pick, and like, truthfully, I'd pick 2 of them I'd like to pick, like I think are decent to pick. One of them, like, it's going to be the least fun one to pick. Which one of those would you like to be called I? What should we use for I? Any ideas? What should be I? We've got 3, 2, 1. Which one of those should be I? This is where you start turning it into a skeleton. Huh? Pick any one of them. 3, 2, or 1. Which one would you like to be I? I'll let you guys decide in the chat right now. You get to pick which one of these becomes I, because then we start turning into a skeleton. Let's see here. See if you guys pick the same one I would pick. When I have 100 people watching, it's so quick on the answers. Do you want to do 3 becomes I, 2 becomes I, 1 becomes I? Which one shall become I? It's like you decide. I might pick, but I want you guys to. How about... Say I think someone wants to pick, and then they're like, I'm going to pick the wrong one. I'll tell you this right now, and here's the great thing. There is no wrong one to pick. There's one that's less fun, and the less fun one to pick would probably be 2, because it's in the middle. It just is less fun. It's going to be, the code's going to not look as cool. So I would probably pick, it says 3 through 500 right here. Because it says 3 through 500, I'm going to call 3 I. I'll explain why right here. So since this is 3 through 500, I'm going to call 3 I. So if 3 is I, what is 2? If 3 is I, what is 2? Well, then 2 would be I minus 1. I know how to work. And then what is 1? Well, 1 is I minus 2. And then what is 2? And you notice I'm putting these in parentheses? Well, 2 is I minus 1. Keep thinking 2. And then 3 is I. Now we know we've done this properly. We're going to check something. Is if we go here and we say I save into 3. Now what we should get is what we got earlier, and we should store into the 3rd position, and we should get the same thing we saw earlier. So we can confirm this. We're going to reinitiate the vector right here and see if we get the same thing. So we're going to look at this right here, and we're going to look at our vector, and did we get the same thing? This confirms we've made a skeleton. This is the key to doing the work, is you need to say, okay, does my code do what I want it to do? And look at it, say, okay, I did the exact same thing as the code above, but now I'm using I's. Well, you could do it yourself right here and change what I is to 4, and then it'll run the code, and you can see, did it put in the right element? It should, and we can see right here what it put in there. By going here and running this, and we have that. You could confirm this code up here by running this, and you can see if it gives you the same thing. So let's see the code up top. Do we get the same thing? And the answer is yes. Our code looks to be working. All that we're changing is what I is. Do you see the pattern? That the number just goes up by 1 each time. Even 2 goes up by 1. Even 1 goes up by 1. And 3 goes all the way to 500. So I could sit here and just change this and keep running the code and just keep running it and keep running it. It's a little quicker than writing them all out. I've kind of got a control panel for my skeleton. You can use 2. And 2's not quite as fun, but you can use 2. And so now let's see with this skeleton right here. Let's take the skeleton and put the skeleton inside the for loop. So now that the skeleton is inside of the for loop, I need to tell it what changes about the skeleton each time, and that's the variable. The variable changes inside of the skeleton each time. Now, what will this go through? Think about this. Remember, I is equal to 3 when this starts. So this loop will go from 3 to 500. Is there a quick way to write 3 to 500? The answer is yes. There's a very quick way of writing 3 to 500, and when we run it, what do we get? We've now stored into X all of this right here, and I'm pretty sure we want you to print the head of it. So after this is done, write a for loop to accomplish this feat, run the loop, run tail, print to the screen the last 6 elements. Here's a sanity check right here. Let's do our sanity check to make sure we're not insane yet. And there's the sanity check, and yes, the sanity check checks out. Oh, sorry, Ivy. So you might, if you, yeah, sorry you're behind. I appreciate it. If you need to catch up, don't worry about it. I think we're on ultra low latency. You can always hit the live button and be watching live, but then you'll skip parts I didn't talk about. But we've done it. If we want to do the tail and do the last 6 elements, we want to do tail of vector x and do this right here, and we get the tail of the vector. Pretty interesting problem right here, and good understanding of what's going on with the code. Once again, I want to reiterate, whenever you write your for loop, write the skeleton. And truthfully, I would say it's only in teaching this class that I've actually kind of looked at the best practices on how to code these things. Like writing your inner part of your code is the best way to do it, because once you get it to work on one instance, you then just have it work on everything. I knew that worked on element 3, and then I just changed it so it just changes what the element is. So get it to work on one thing and have it do exactly what you want it to do, and then get it to work on just everything. Because if it works on one and then you can just change what it does, you're good. Really great questions right there. Ivy or anyone else, additional questions, but really good stuff, and great job working ahead. I know this one isn't due for like a week, but that's what we want you doing. We want you kind of checking stuff out, being ahead, and asking those questions, because then when you come to class, it definitely makes a lot more sense. And these are tricky problems. They are tough. We really want you to get a deeper understanding of what you're doing, and you have to look at it, and you have to be like, and then you have to come with a question. You have to be like, well, why doesn't this work? And you have to kind of hit those speed bumps in learning, where you just have to slow down a little bit and be like, okay, I have to think about this. And it's building a skill set. I think one of the biggest things, this is a little rant on coding, is it's like playing piano. No one wakes up one day and just says, I'm going to be the best pianist out there. You have to say, okay, I'm going to practice piano. I'm going to get better. And you do it over weeks, you do it over months, you do it over years. And then you look at the people like Ben Folds, or people who I think are absolutely amazing. They've been playing their whole life. And especially with a lot of younger people now, they're learning how to code at younger ages. And I think that really gives them an advantage, because for me, growing up in the 90s, computers were pretty new. I mean, they were around, but someone had a home computer, like, oh, cool, you got a home computer? Whoa. And then you go to college, and it's like most people have computers, but then by the 2010s, it's like everyone has computers. And now in the 2020s, oh my gosh, 2020s, everyone has an iPhone. Not everyone, but you get what I'm saying. It's so ubiquitous that it's commonplace. Someone's like, oh, let me pull up my iPhone. I remember when someone first had an iPhone, I was like, whoa, you have an iPhone? Like, yeah, I got an iPhone. You're like, now it's like you don't have an iPhone, or you don't have a Galaxy, or you don't have a Pixel. It's like the world has changed, and we see different kind of introductions to technology at different ages. So people nowadays growing up coding, if you have that, which a lot of schools do, they have a huge advantage to where, like, I think I'm a pretty decent coder, but then someone coming up who grows up coding, all of a sudden they get to my age and they're like, I've been coding for 25, 30 years. And we're like, what? That's awesome. And it'll be like riding a bike to them. They'll be like, oh yeah, just code this. It makes all sense. So the more experience you have with it, that's what I'm getting at, the better you'll be. So don't expect it to be like one day you just can do everything. It just takes time. It takes practice, and you have to put in the time and the hours of getting stuck. It's like the first time you play a new scale and you just can't play it correctly. So that's got it. Let's do it as I move around my contacts. Questions in the chat. If you have a question, feel free to ask. Blah. Contact is now fixed. We are good. Who has questions? Might head out a little bit early. I said to be here till about 4:30 today. And thank you everyone for coming by. We did a few 201 questions. We had some 474s, and these are of course recorded, so you can go back and watch them. I might try to do some like standalone like help videos on these. But definitely coming in here, asking questions, and trying to better understand what's going on is a really good way to know what's happening. And I think I might raise up my volume a little more on this. Let's see here. How's that on the audio? Let's go here on audio. It seems like audio is good. And there we go. Just making some final adjustments for class tomorrow. And I'm going to see how this sounds tomorrow. But we'll stay for another 5 minutes or so, and we'll see if anyone has questions. We've done a lot of topics today. So if you're still watching, ask the question in the chat and I'll answer the question. Let's see. I'll write another for loop here. I'll do one of my favorite examples. So one of my favorite examples is writing a function that will solve kind of your 9 times tables. So this is kind of a fun example that deals with functions and deals with for loops. Because like maybe you want to make a function where someone can just be like, I want to see my 5 times tables. And so you think about what you want. Okay, we want to do something where we say cat, paste, and then we go here and we say 9, and then we go 9 times, we go right here and we need new arguments in this. We're just going to paste a sentence together. 9 times 9, and then we'll go here is, we need another comma here. 9 times 9 is, and here's the fun thing about coding. There we go right there. And so feel free to ask any question you have. And right here, 9 times 9 is 81. 9 times 9 is 81. If you notice, I didn't have to solve for what it was, and we're going to make it a little bit easier to see the code here in a moment. Let's go to 9 times 1 is 9. Kind of an easy thing to understand right here. If you notice, I'm already changing what I want to change right here. I'm changing the number. So you know what we can do? We've already got our for loop ready. This is our skeleton. We just made the skeleton. Do you see how I'm changing this right here between numbers to like 2? And good to have you here in the chat. Ask any question you have with statistics. We're good to go on stats questions. If you see right here, we have 9 times 2 is 18. So we've made the skeleton. If you think about what we just did a moment ago, let's take the code and put it inside of here. So we're going to put it inside of the for loop as the skeleton. But now we have to think about what becomes our placeholder variable. You could literally call it variable if you want. We'll do that for the moment. We'll change it in a moment here. But if you notice right here, I'm going to change this to variable, and I'm going to put this through the vector 1 through 9. This means the first time it runs, do you want to work on question 2? Yeah, we'll do question 2 here. I'll do it next here, Ivy. So we have here, it's going to go from 1 through 9. It's going to change what variable is. Variable is just a placeholder. And what do you see here? Now, I do want to point something out. It doesn't look so nice right now. That's because it doesn't have a special character at the end of this. And so we need to go here. We need to add another argument for, I think it's \n, which starts a new line. So \n is a special type of thing that changes it so that that starts a new line right there. And so 9 times 1 is 9, 9 times 2 is 18, rather than the bulk output we got right here where it just kind of put it all together into one output. So 9 times blank is blank. What's really cool now is we're going to take this, we're going to turn this into a function. So literally like with for loops, you don't write a function by writing your function in it. You write what you want and then you turn it into a function. So I'm just going to take this and write fun for function and then drop this inside of here. So this is the function I want to manipulate. I want to change what number is being used here. I want to make a 9 times table or a 2 times table or a 3 times table. So all I'm going to do is call this variable x. And we're going to call this times table. So what needs to change? Well, x needs to change. This will give me the ability to manipulate x. So, and this needs to become x. So whatever I put in there will become x. And then we can make a times table right here. I know this is a quick example, but I really like showing what can be done with coding, that if we have our times table right here, I can just enter in 3, and we get our 3 times table. You can do whatever you want. You can put in 6, and you get that. Maybe you don't want to go to a certain number, so we're just going to call this y right here. Or let's call this stopping point, stopping. So now we're going to go here, and we're going to enter in stopping. And now, since we have a stopping point, we could just do a 6 times table to 5, and it literally gives us a 6 times table to 5 because whatever I enter in for stopping changes it. You could call this right here number. Might make a little more sense to call it number. So that means this needs to be called number. We need to have it called the right things in the right spot. And let's call this stopping number. And let's go here and change that. A little better for someone who's reading our code later on. And we got that, and there we are. That's what's happening right here. And last but not least, you can add in some defaults. Like if you notice some of your arguments have defaults, we could have the first number here be 9, and we could have the second stopping number be 9. And look what magically happens now. If we run our times table with nothing inside of it, we get a 9 times table like that. If you notice this was built from scratch, we just try to build our code and understand what's going on and try to add new elements. I also want you to notice how many times I ran my code while doing this. I kept adding new things and reevaluating the code to make sure it was doing what I wanted. There's been multiple times where I've made mistakes in code and it just explodes, everything goes haywire. So run your code multiple times while you're creating it. Don't just write all the code and then look at it afterwards. Let's do one more question right here. Great question in the chat to do question 2. So let's hop down to question number 2. Oh, there's a fun one right here. We're going to make some new colors right here. So when we look at this right here, this is kind of the reverse of, is this the one you want right here? Question 2. Are you looking at this one? Are you looking at the EX stocks? Are you looking at EX stocks? Are you looking at question, is it 1B or 2, Ivy? Which one do you want, 1B or 2? So which one do you want? Is it 1B or 2? I think it's back in time. So 1B or 2. Said question 2, so maybe I'll do 2. Let's take a look at 2. Consider the EX4 stocks from reg class. Each column contains historical prices, information for various stocks, indices, and commodities. Create an empty vector called span and use a for loop. Okay, so first thing I see right here when I'm reading this is create an empty vector called span. So when I see create an empty vector from span, I'll do it. So create an empty vector called span. That is how we create an empty vector. If you see it, do it, especially when it's like that right there, when it's like create an empty vector for span. Got it right away. So use a for loop to define each element one by one. Okay, we're going to use a for loop. Specifically, element I of the span should be the difference between the largest value and the ith column. Okay, so we're going, if you notice, we're doing it by column right here. That's a big key thing, is we're doing the largest value in the ith column minus the smallest value. So it's the difference, so it's subtracting the two. And then we need to do it, and we need to print the tail of the span vector. And then the result is provided as a sanity check. Cool. Love sanity checks. Make sure we have it correct. Okay, so let's take a look at the EX4 stock data frame. Okay, so we've got a bunch of stocks and indices right here, and it's important to know what we're doing. I'm going to take a screenshot of this. I'm going to head over to Word to show you what exactly we are doing mechanically inside of R. So if you think about this right here, we have different columns. Let's grab this right here. Let's go into Word and go to a new document. Go here and paste it in. So here's what's happening. We are going to a column, and we're going to take all the values right here. We need our orange pen. We're going to take all the values inside of this, and there's even more. We just have a limited print to the screen. We're going to find the smallest value, which looks to be this one right here. Then we're going to find the largest value, and I know there's more values than these, but we're just using this as a limited thing, and then we're going to subtract their difference. Then we are going to go to the next column, and we're going to find the smallest value here, and then we're going to find the largest value and take their difference. And you're hearing the repetitive nature. We're going to go to this column here. We're going to find the smallest value. I'm trying to figure out which one's the smallest and largest very quickly, and I might make a mistake. There we go. That's the largest it looks like. And we're going to take their difference. So do you see the repetitive nature? Go to a column. Find the smallest value in that column, find the largest value in the column, and take the difference. Go to the next column. That's where the control panel is really going to help us. But this right here is the skeleton. That's the skeleton. Go to a column and subtract the difference between the largest and the smallest values. Like you should be able to kind of think like visually what's going on here. We're going to go to a column and subtract the largest and the difference between the largest and the smallest value. So we obviously, you think about your tasks. You have a kind of a first task right here is 1, go to the column. 2, find these values, and kind of 3, subtract their difference. So, you know, you need these values, you need to go to the column. So let's talk about how we are going to go to the column first. Let's hop over here, and let's talk about how we're going to get to that column. There's a lot of ways to get to the columns. One, this is a way I would not suggest. This would be a not fun way, is you could do the $, but that's going to be harder to change if we're doing it. Another way to pull the first column is to go positions, and this is a data frame, so it's 2-dimensional. So we go to position 1, and that's column 1. We go to position 2, and that's column 2. So if you were to look at the data right here, you can see the first values, which we see inside, like 405, 409. That is literally the values you see right here, 405 and 409. 47 and 48 can be obtained. We'll go back to R if I change this to column 3, and I think I said 47 and 48. And if we look back at the first values right there, there is the 47 and 48, confirming that we are grabbing column 3. Always kind of look at it and be like, am I grabbing column 3? And as if you ever need to remember, this is rows, and this is columns. If you forget which way it goes, just remember, I want to rock. That's what you do. If you get your rows and your columns confused, it's always I want to rock, rows and columns. Rock, rows, columns. R-O-C-K, rows and columns. I want to rock. So that's the way I taught my students when I used to teach this, because it's like, is it columns, rows, rows, columns? It's like, I want to rock. That's the way you remember it, rows, columns. So this is the column space right here, because the first one would be row space and the second one is column space. That is column 1. By leaving the row space blank, we get all of the rows in column 1. So now that we have this, why don't we just take the minimum of it? If you notice, I'm wrapping my code up by selecting it and then putting a min around it. So now I know the min, and you probably know what we're going to do next. If we want to do a range right here to figure out the span of it, we're just going to copy our code, we're going to subtract some differences, and we're going to double-click this, and we can change it to max. If you double-click the name of the function, you can just change the name of the function, and there you go. One thing I want to point out, and this is something I'm always trying to teach you guys how to code quicker and more efficiently. If you are anywhere on a line and you want to run it, you can just hit Control or Command Enter, and it'll run that line. You don't have to highlight the line. You can if you want. You don't have to be at the very end of the line. You can if you want. But if you're anywhere on a line, it'll evaluate that line. So it's just kind of being quicker. Think about how many lines you evaluate. And if you have to take an extra second or 2 seconds to click to the end of it, if you evaluate 100 lines of code each week, that's 200 seconds, 3 1/3 minutes. And that's every week. And then you're doing like an extra hour you're losing. It's like you're just spending an hour a year going to the end of the thing. It's like quick, code faster, code quicker, code more efficiently. That's what we do. Okay. Enough of that rant. So now we have the spanage of column 1. Well, guess what? Let's go here to span and let's store into element position 1. I do want to mention something briefly here. Line 105 is not part of the skeleton. It's like some alarms. I should have an alarm button where my screen starts blinking and being like, line 105 is not part of the skeleton. Line 105 creates the span over here. If you notice, let's rerun it. It's going to create a null element or just a null value. It just creates kind of a box. It's like I'm going to put things into that box, but there's nothing in that box now. There's no values. There's no nothing. I know when I say there's no nothing, I really mean that because nothing is NA. NA is missingness. So there's no nothing. It's null. So it's weird. Code is weird. So what do we have right here? We have our skeleton. And so I can run this as a skeleton if I want, because now I just put a control panel out here that I change, and now I change this to I. It doesn't have to be I, but a lot of times for positions, I makes sense. But if you notice what I'm doing is I'm going to show this works by going here and putting I's, and then it works with that equal to 1, and then I store this as 2. And if you notice span, look over here, span is actually increasing in the elements, and we're going to change this to 3. And you know what I'm going to do is I'm going to leave you guys here with this because I want you to think about this. And we still have online office hours before the assignment is due next week. But I think this is a really good start on this one. I mean, we're literally just moments away. I built the skeleton. Now you just have to figure out the control panel. And to get the control panel up, see, even I just want to complete it. I want to be like, just take this and put it inside of here, choose your variable name, which we've already chosen, and then figure out what it goes through because it has to go through all the columns. As the biggest hint I can give is it has to go through all the columns. I don't know why I'm whispering, but it has to go through all the columns. Be careful. I want to say this also, whatever you put up here, this is not the answer. But if you were to put something like this right here, evaluate it. Evaluate that and see what it's going to do. That means when it runs, it's going to run the first time with I equal to 1, I equal to 2, I equal to 3 as it runs, as it keeps running. And this is where it's changing it. Like this right here is this control panel right here that I'm changing. Like when my code runs, it'll run like this. So that is what it is doing. And I hope that helps it make more sense, but it doesn't do that. It goes to here. But this is what runs when you put the control panel to this. It goes through and iterates I through all those elements and runs the code this way. I'm probably going to head off here at 4:30 because I'm going to get a little bit of food and go to a presentation tonight. Are there any last questions? How is everyone doing? I hope that really helps out with some of the problems on this next assignment. I know for loops are a little tricky, They're fun to do, and they really help out. They're a huge time saver. Is anyone still here? Anyone here to say hey or goodbye? I'm ahead. I said 4:40 today, but I'm gonna go grab some stuff before the meeting, and we will see. I think that does it for today. But we did a lot of great questions. We covered some 201. We covered some 474. That's got it for the moment. But I'll say goodbye to everybody, and we will see 201 tomorrow, and we'll see 474 tomorrow. So have a great evening, and I will see you